we'll have to like move things around to make things better. It's going to be a real laptop day. But I'm looking forward to that a lot. As I said, there are the guided quote-unquote workshops, and then you can play with any technology that you like. There's a couple of vendors here with great stuff. We had some talks yesterday where people talked about interesting technology. Tara posted some links to, I know there was some interest in the Lambda stuff, so there's on the program page, there is, under her talk, there is a link, and that's a couple of slides which have links in them that she had in her slide deck. So if you want to try that out, look at that, and that has some places to get started. Other than that, yeah, there's an open spaces session. So we start off after the first two talks with an open spaces session. You know the deal by now. If you have any topics, you put them up there. We might, depending on how it goes, have another one of those Ignite sessions where we embarrass people by making them to come to the front and talk to the crowd. We'll see. In any case, don't forget to vote. You know the drill. We'll have 4 discussions. Lunch, it may degenerate into another working lunch like it did yesterday, which is fine. It depends a bit on when lunch is delivered. Otherwise, feel free to go and graze on that stuff. So, having said that, obviously thanks, as I said again, for those who made it out today. And thank you to CoreOS who are making it possible for us to have lunch. And then, of course, also Cluster HQ later on in the day, who will be sponsoring our, sorry, CoreOS is doing breakfast, Cluster HQ is doing lunch. You can see how much I need my coffee. Anyway, so let me pass this over to Jonas, who will say a bit about the prerequisites for the creating multi-container apps with Docker Compose and Panamax, and then Dave will say something about the other one.
Awesome, thank you. Yeah, so it's one of the longer titles for the workshop. It's a workshop around Docker Compose and Panamax. Anyone ever played with Docker Compose or Panamax? A few of you? Okay. So this is pretty much for someone that has already created and run a few containers, and you want to learn how to connect your containers together and run multiple containers in tandem. So essentially the next step after a Docker 101 course. So if you want to learn how to write Docker Compose files, run containers in tandem, I think it's going to be a fun workshop. So the prereqs for this is essentially boot to Docker, or Docker if you're running a Linux desktop. So boot to Docker and Docker Compose. Both of them are in Homebrew if you're on a Mac, so it's really easy to install. Otherwise, it's just a few megabytes to download. The third prereq is, of course, Panamax, and that's also a very, very small download, but I highly recommend you do it before the session instead of doing it at the session, because then probably a lot of people will hog the bandwidth. So it's going to be a lot of live stuff. We're going to work together, and I'll show stuff on the screen. You'll work, and things will break, and we'll fix it, and we'll have fun. So yeah, we start with that at 12:55. Docker Compose, Panamax. I think it's in that room. Yeah. So we got 40 seats. So get there early if you want a spot. Thank you.
Same time. That's not right. I want to be in your session. All right. No. Don't go to his session. Okay. So another option you have is at the same time at 12:55, and also, by the way, at 3 o'clock. But unfortunately, it's not this. It's not a repeat. They're actually a continuation of the workshop. So the first part of the workshop. Oh, the title is deploy your first container into, and then we put CoreOS, Cloud Foundry, Azure, and AWS. We're actually going to focus on CoreOS as the deployment environment. And the workshop's going to have 2 pieces to it. There's first going to be, okay, get your boot to Docker going and create your container. And then we're going to push that up onto Key or Quay. I'm not exactly sure how you pronounce that. And then that's a container repo. And from there, we'll pull it down into a CoreOS environment. So I think that's going to be actually on AWS, but it'll be a CoreOS environment. So it'll be hands-on. The key takeaway is if you're going to come to that, in fact, you should do it anyway. Just download and run boot to Docker on your laptop beforehand, so we don't have to wait for that, because what I noticed yesterday is at certain times the bandwidth can get saturated, or maybe they're limiting. I'm not sure what they're doing on the back end. What's that? Yeah, that's okay. So that's very important. So keep that in mind, that you should download that, like start downloading, not everyone at once, but start downloading that.
Discuss amongst each other who goes first.
Yeah, and I do have it on my laptop, so I can share a key and all, but I'd just rather have you guys do it ahead of time. And yeah, look forward to seeing you there. Oh, and I'll be doing that with Boyd from Stack Engine's also going to be helping. He gave a talk yesterday where it was talk, and then we're going to take a lot of what he talked about yesterday and actually do that in the workshop. Okay. Oh, and the other speaker is Barak from CoreOS.
So actually, so you've got CoreOS running on AWS. You get both for the price of one. That's pretty nice. So yeah, what was this going to say? I've kind of forgotten now. Yeah, it's sort of the dining philosopher's problem. It's now the downloading developer's problem. Like, who gets to get the bandwidth? So one final thing I forgot to mention. Yes, we have an open spaces, but if you want to try one of the other technologies, we're going to use the same idea. If you look at the board outside, there are the other two spaces, and we're going to use stickies in the same way. So if you want to play with some technology, you make a sticky. Say, I want to try Kubernetes, Lambda, whatever, and then we'll vote on those as well. So that way we'll pick what stuff gets. And I mean, again, that's two spaces. Nobody is stopping you. There's so much space we have here. If you want to sit with somebody on a bench somewhere and hack on something else, then by all means go and do that. It's your conference, not mine. So thank you very much. And I guess now we'll turn it over to Gear, who will do a really interesting talk I'm looking forward to on end problems of Linux containers and some solutions.
I'll use this mic. Oh, good.
As long as you don't blow Jared's.
Morning, everyone. I think I'll just use this. You can hear me well, right?
Jared, you good?
1, 2. All right. So this is a talk about various obstacles that we came across while developing Linux container technologies, and the way we solved it, the way we succeeded, the ways we failed, and so on. This is all sort of more low-level stuff, mostly kernel stuff. So I'm not talking about orchestration. I'm not talking about PaaS. I'm talking about mostly the underlying technologies, the ones that enable stuff like Docker or CoreOS. So my affiliations are, I work for Odin, which used to be known as Parallels before last month, and they rebranded. And the projects I'm working on are OpenVZ, Virtuoso Containers, and Creo, which is checkpoint restore in user space. Both projects are open source. Both projects are for Linux. And the first problem I want to start with is the problem of doing effective virtualization. And by virtualization here, we mean partitioning, a way to divide a big server into multiple smaller ones. A historical way of doing that was using hardware capabilities. Back in 60s, as Jeff was talking about here yesterday, they have big mainframes, and universities can only afford 1 or 2 such machines. And a university is big, and there are many users. So the way for this machine to be used by many different people was to partition one physical piece into multiple smaller ones, and it was done mostly in hardware. And the modern way of doing that, or let's say used to be, is virtual machines, because current CPUs are fast and you can afford spending a lot of resources for doing virtual machines, which is basically emulation of hardware, give or take. And the problem is performance overhead. Because then you virtualize things, then you run virtual machine, you need to spend a lot of cycles, a lot of CPU cycles, a lot of power on doing just that, virtualization. The partial solution to that is vendors like Intel and AMD, they provide some hardware support. It's like Intel VT technology to cut the corners and do it in a slightly more effective way. But still the overhead is pretty big of virtual machines. And the solution here is, I mean, it's sort of obvious. It's hidden in this conference name. The solution is to isolate, solution is isolation. What containers are doing is basically you have one single piece of hardware and one single kernel, and on top of that you run multiple isolated user space instances called containers nowadays. So on the usual system, all the processes, they form a tree and they see each other and then they share common files. They can send signals to other processes. They share the common network stack, memory, there's a common set of users, everything. So the idea of containers to make all those resources private. And this idea comes a long way back. There was one historical way to make those resources private, some of those resources, and this is truth. That I think it's from like 1878. Truth appears in Unix, and it allows some process to have its own files, not shared with the rest of the system. And that idea was used to run some services that might be compromised, for example. And if you run something inside that root, if you compromise it, you only see your own files, but not the whole system files. So this is sort of the protection. But that root is basically a sort of ancient container. Of course, it's not enough. It's just the file system. There is much more to it than just the file system. So in modern Linux kernel, as well as Solaris, AX, and nowadays even Windows is doing that. In Linux, we call that namespaces. So basically, we implemented something in the Linux kernel, something similar to root, but for different things. First of all, there's a PID namespace that makes it possible for you to have your own process tree, not shared with the rest of the system, so you can hide your processes from others. Then there is a network namespace, and the network namespace means you have your own network devices, IP addresses, routing tables, firewall rules, network caches, everything that when you think of networking on the server, everything that's networking, it can be separated into private network namespace. Then there are like IPC namespace that takes care about shared memory, not shared with the rest of the system, semaphores, message queues, and there is a mount namespace, which is sort of like root on steroids with some added features. Then there is the user namespace that makes you possible to have your own UIDs, group IDs, and so on. All that can be enabled in the kernel. You call the clone system call with clone new whatever flags, like clone UNS, clone new PDNS. This is the way you employ that. And with all those namespaces and truth, or mount namespace instead of truth, you can have container. So You spawn a new process into its own private namespace. You don't see any others. You're now isolated. The next problem that comes with it is it's still the same kernel. It's still the same piece of hardware. And all those containers, while being private, they still share the common set of resources, and those resources are finite. CPU, RAM, disk, and a lot of other stuff you probably wouldn't think about. And the problem here is you need to distribute those finite set of resources between various containers in some efficient manner, so every container can have its own share. And you also need denial of service prevention, so those containers that not stepping on each other's toes. So if someone runs a fork bomb inside the containers, other containers shouldn't be affected. So that's a problem of like isolation. You also need priorities. You want to have high priority container, low priority container. You need some SLA, service level agreements. You want some guarantees, basically. And there are a lot of approaches to that. So these are containers. And you need to have those walls in between. One solution that we did before and is still used nowadays is OpenVZ resource controls. And we have a few things in the kernel for the resource management stuff. First of all is we have so-called user bin counters, which is per container set of about 20 different parameters that you can control on per container basis. The parameters are like user memory, kernel memory, number of open files, number of processes, various memory related things like size of network buffers, which can also be abused. And therefore you have to control it. The other thing is the hierarchical CPU scheduler that schedules on that distributes CPU time between containers first, and then inside the container it distributes the CPU time between tasks in that container. Without the hierarchical CPU scheduler, the more processes container has, the more CPU it gets. And of course, it's not fair. So we need to schedule on a container, between containers first, and then within the container. The other thing, since containers share the common file system, and basically a container file system is just a directory on the host, you need to have disk quotas per directory. And that was usually not available from most of the file systems in Linux. So we have to implement the per container disk quotas. It's basically per directory disk quotas. And finally, there's I/O priority and I/O bandwidth limit, which is also per container. So you can say no more than 3 megabytes per second for this container. Otherwise, they might abuse the I/O and trash the I/O subsystem. One thing that I'm not mentioning here is network priorities, but this was the only area of Linux that was good enough, so we didn't do anything in there. It was all done before us. The network stack in Linux is pretty good, and it supports all stuff like limiting prioritization and all that. So we're just using the existing stuff. Everything else we have to redo or develop. Good thing about all this stuff, it's all dynamic, so you can resize everything runtime. You need more memory, you resize it. You need more CPU, you resize it. You need less CPU, you need to, put the container into the corner. You can do that too. The bad thing about this, it's pretty complicated to set up. As I said, like 20 parameters for user bean counters, they're all interdependent, and our users were all like that. Really, really hard to configure. What we did is we wrote a book, a whole book about user bean counters. It's about 200 pages, explaining all the gory details about that. But it was still not enough. We ended up with next generation resource management, and it was called vSwap. And this is what we use nowadays. Basically, all those 20 parameters can be boiled down to two things: amount of RAM and amount of swap per container. In addition to that, there are also CPU limits, CPU priorities, I/O limits, but that is not hard to grasp. RAM and swap are also, seems natural. You don't have to explain what it means to give container that amount of RAM and that amount of swap. And for network buffers, it's a different thing. You have to explain there are TCP receive buffers, TCP send buffers, and all the different things. So this makes it simple. Other parameters, they still exist, and you can still use those, but they are becoming optional now. And one good thing about this, that the swap you give into a container is not the real swap, but a virtual one. What it means is if container is going over the RAM limits, we put some of its RAM into swap cache, and swap cache is in RAM 2. So no disk I/O is happening if it's not necessary. And only if there is a global RAM shortage, the actual swap is occurring. Also, when the container is going over its RAM limits, we artificially delay it, so it feels like it's swapping, although in reality it's not. We sort of punishing the container for going over its RAM limits, or we emulate the effect of the real swap. So this stuff is currently only available in the OpenVZ kernel. It still haven't been ported upstream. What we have in upstream is a bit different. Google were using containers for about 10 years, I guess, and they had the same problems of resource management. And they took one mechanism that was written by Silicon Graphics, I believe, and the mechanism was called CPU sets. It basically gave a way for groups of processes to be bound to groups of CPUs. And C-group was a further development of that mechanism. It's just basically they generalized it, so it became possible to group sets of processes for applying various resource controllers to those groups. I mean, in Unix, in Linux, traditional Linux, all the resource limits are usually per process, per single process. And the traditional way to control that resources is the U limit. You can set like limit RAM for the process, limit number of open files, but all these limits are per process. And the modern world is we don't deal with processes, we deal with process groups. With or without the container, each service that you run is usually a set of processes. Like MySQL or Apache is a set of processes. And it doesn't really make sense to apply limits to single processes. We need process groups. So C groups is just a mechanism to group the processes. On top of that, there are controllers. that you can apply to those sets. And the controllers are like block I/O, CPU, devices, like which devices you give to those groups. And then there is an interesting controller that is called freezer. It can freeze this group of processes, so it won't run. Then there's a memory controller and few network controllers and so on. Now these C groups are orthogonal to namespaces. You can use namespaces to create containers. You can use C groups to control groups of processes. But then you apply both C groups and namespaces, you get the container in its modern sense. It's still a work in progress. Like, we would like to contribute our vSwap technology to upstream. We haven't done it yet. We just finished adding the kernel memory controller. Because if you think about it, if you think about the processes running on the system, they allocate some memory directly, like doing malloc in C, but they also allocate some memory indirectly in the kernel. Like when you fork a new process, there's some amount of kernel memory allocated for that. So it's not that you are allocating it, it's the kernel allocating it on behalf of you. When you send a network packet, some memory is allocated in the kernel, and it's all done indirectly, but it still needs to be controlled to prevent the bad things from happening, to prevent the denial of service attacks and so on. So for that, you also need to control the kernel memory allocated on behalf of the user space processes. And this is what KMM controller does. So it stops running. But it's not stopped in the traditional sense. It just sits there, it's just not running. So we freeze the container, and then we dump the complete state of in-memory of the processes from that container. We dump all this to a file on disk. Then we copy that dump file. It's like a snapshot of the in-memory state. We copy that dump file over to the destination server, and when we undump it from there into RAM, basically recreating all those processes, I don't know, network buffers, connections, open files, everything that we had on the source server. And then we unfreeze, and it continues to run as it were, just on a different server. So this is what live migration looks like. Of course, it's a huge RAM, the dump file is huge, and it takes a lot of time to dump, copy, and undump. A long time means usually seconds, but it might be still, you know, if your SQL query should run in a few microseconds, and when suddenly it runs in seconds, it might be a problem. So one way to optimize this process, we're trying to optimize the time that when the container is frozen. One way to optimize it is use network swap device. What we would do in this case is we dump some minimal memory, like the minimum needed memory, and we'll lock the rest of the memory on the source. Then we copy that minimal dump and restore that minimal stuff and mark all the other pages that are not there as swapped out pages. And then we provide a network swap device. Source server RAM acts as a network swap device for this container. And we unfreeze, and it starts to run, and it hits those pages that are not there, and those pages are then brought in from the source over the network. That way we can migrate way faster. And when we preventively migrate all the rest of the RAM and kill it on the source. And this is very useful. This works. You can bring the frozen time down from seconds to sub-seconds with this technology. But there is a big problem with that. The problem is there is no way to roll back. What it means is when we are in the state, when we have migrated the container and it's already running on the destination system, and we swap in things in the rest of the RAM, we swap the rest of the RAM in. If the network connection breaks at this point, we are doomed. There is no way to fix this situation because it's already running here on the destination, but some pages are missing and we can't get them because of the broken network connection. We have everything on source, but as it's already running on the destination, we can't go back. So this is the problem with this particular approach, and we figured it the hard way. I mean, it was all done, implemented, and it was all good. But when we started hitting that situation of the broken network connections, and you know, you ruin the container. If the network connection is broken, you ruin everything. And our users were complaining a lot. So we redeveloped everything by doing iterative RAM migration. This is sort of the same thing, but with this scenario, we can do rollback at any time. Basically, what it does is migrates the RAM before, not after. So what we do is we have the in-kernel memory, in-kernel mechanism to track modified pages. And we ask the kernel to turn this on and to track the pages in RAM that are modified for us. And then we copy all the memory to the destination system while our container is still running, up and running. We copy all the memory over. When they ask the kernel which pages were modified, and we copy those modified pages again. And we do it again and again and again, iteratively. A few times, maybe up to 10 times. When there is, we do that copy, and at some point we think that's enough, and it's time to freeze the container. We freeze the container, we do last copy, and when we unfreeze it. So, this way, if anything goes wrong, we can stop the migration and resume the container on the source. We can roll back anytime. When the container is up and running on the destination, all the memory is there, it's all good, we can kill it on the source. We no longer need to roll back. So, unlike the network swap, this iterative RAM is, let's say, unbreakable, or more unbreakable. So, let me go to the next problem that we have. The problem is pretty common, and it's not just for us. The problem is we developed OpenVZ containers separately, like in a closed room full of developers. We were doing that. We were releasing our stuff as precompiled kernels, or sold it, or just was giving it away, but it was not upstream to the mainline Linux kernel. And this is what other companies did a lot too. Like IBM had lots of Linux projects. What they did is they have good engineers, they develop some technology, and we test it, they document it, it's all good, it's all ready, and then they bring him on the plate and say, okay, upstream guys, take this. And upstream guys don't want to. They don't want to because there's nothing to develop, and they don't like stuff that it's completed. They need to work on that. So, this is the photo from my yesterday's presentation. When you try to upstream something, this is what happens. a lot of times. So yeah, that's this big bear is Linux kernel subsystem maintainer, for example. So you have lots of good patches, you send it upstream, and they're rejected. They say like, we're not interested, or they say, this is not the way it should be implemented. One solution, but we still want it upstream. We still want everyone to benefit from the technology, and we want it in the upstream kernel. One way to fix this problem is to rewrite it from scratch. Basically, this is what we did. For example, our user bean counters were never accepted, but in C groups and various controllers appeared in the upstream kernel, so we were working on that controllers to replace our user bean counters with some of those controllers. Same happened with the process ID namespace. We did 2 iterations. We rewrote it from scratch, then IBM also rewrote it from scratch, and neither got accepted. And then we rewrote it from scratch once again, and it finally got accepted. Network namespace was written from scratch, and it's a pretty huge thing. I think it's about 500 patches. It's a pretty big thing. And it works this way. It takes a lot of resources, takes a lot of engineers, takes a lot of sleepless night, but it works. But this is not the only way to get something upstream. And there is yet another way. Other big technology that we have is checkpoint restore, which is used for live migration, as I explained earlier. And we tried really, really hard to merge this to the upstream kernel. But what checkpoint restore does, we have it in the kernel. It basically takes care about every subsystem, everything that kernel knows about. We need to be able to checkpoint it into the dump file and restore it, like processes, open files, network connections, buffers, whatever else is there, shared memory, semaphores, I don't know, signals, lots of stuff. So we tried merging this into upstream Linux kernel, and no one wanted to see our code in there because it infiltrates each and every subsystem in the kernel except maybe for drivers. And no single maintainer wanted that extra crap in their code. And there were other people who were trying to do the same. They had their own implementation of in-kernel checkpoint restore. I know a person who spent 3 years of his life trying to merge this to the upstream kernel, and he failed as well. So we are not the only one who failed. Yeah, it's good to be in a loser's company if you're not the only loser. So we were not able to put it into the kernel, and we circumvented the system by re-implemented it in user space. If we can't do it in the kernel, let's do it in user space. It was a pretty crazy idea. The first time I heard about it, I say, it's not gonna work. You're totally crazy. Please work on something else and forget about that. And this was actually the we got the same reaction from the upstream kernel developers too. They were saying something like, the project bought various mad people who trying to do things that are not gonna work, but let them try. And they specifically asked us to have all this, well, we can do it in user space, but there's still some things needed from the kernel, here and there. Mostly the idea is this, everything, I mean, not everything, a lot of stuff, you can get a lot of knowledge about the processes running by looking into /proc file system. You can get the PIDs, open files, and so on. You can get the network connections. So theoretically, there is a way to get it, all that information, and then try to recreate it on a different system. This is the checkpoint and restore. Practically, some things were missing, and we need to add some stuff, bits and pieces here and there in the kernel. But it was pretty minimal. With about 150 patches, we achieved everything. And those patches, they specifically asked us, they said, it's not going to work, but we'll give you guys a try. But please put it all into if-defs so we can cut this crap out. Well, then we will realize it's not working. And then later they realized, and we realized, it is working. So the project is called Crew Checkpoint Restore in User Space. And I think we achieved our goals. It is upstreamed. It's mostly in user space. We can't get it into the kernel. The kernel part is about 150 patches, I said. Currently, Crew tools are at version 1.6. Google and other guys are using us. LXC and Docker are using us. Recently, I think it was Docker 1.5 that got Docker Checkpoint and Docker Restore. And underneath that, it uses this Crew thing. And on top of that, we have a separate project called p-hole that takes care about live migration. Because Crew is only about checkpoint and restore. And that p-hole, there's a thing on top of that cares about live migration. And this is our kernel patch statistics, specifically for Crew project. There's not a lot of patches. As you can see, we merge most of it to kernel 3.10 or so. And currently, we have only 1 or 2 patches per kernel release, mostly fixing some things, and we have 2 patches pending. Much stuff. So this is the way to merge something by not doing it. Yeah, and I believe this is the final problem I'm going to talk about. This is the problem of common file system between containers. We also realized it the hard way. Traditionally, we were using truth for containers. And when we found out that many containers, they shared the common file system, they shared the common file system journal. And if you do a lot of metadata operations, like you truncate a file by 1 byte and you do it a million times, the journal becomes contended, file system journal. And it's a bottleneck, and it breaks the isolation between containers, because one bad container can do this bad thing and all the other containers will suffer, leading to seconds of delays doing I/O. And other problems are no sub-3 disk quota that we had to rewrite, no snapshots, and there are some other minor things like file system is the same for containers, so file system properties like block size are the same for containers, and this might be not what you want. So that true thing that was a solution early now became a problem. One way to solve this is use LVM, basically have your own block device and your own file system for every container. The problem is it only works locally on top of the local block device, so you can't do some network storage. And it's really hard to manage, like you have a partition, LVM partition on this disk, how do you migrate it to a different disk? It's really a hard thing to do. And then with LVM, there is no thing provisioning, meaning if you want 10 gigabytes for your container, you have to allocate those 10 gigabytes in advance. So other solution would be to use a loop device that's available, loop block device that's available in the kernel. But this is pretty inefficient because everything is cached in the kernel in 2 places, like wasting lots of RAM. Then there is also no thing provisioning, and there's very, very limited feature set of the loop device. That loop device is what you usually use to mount an ISO image, that loop device. So one good solution to this is use ZFS and ZVol technology that came from Sun has a lot of good features. It has thin provisioning. You can have file system in a file with zvol. You can do deduplication. You can use send receive to migrate the data over the network in a very efficient way, similar to the way we migrate the memory. But ZFS licensing is not compatible with the Linux kernel licensing, so you have to ask your users to install it. You can't really distribute it. And Linux port is, I think, it's still not mature enough. It works very well on Solaris. It doesn't work as good on Linux. And in 08, it just was not available at the time. So we ended up writing something called ploop or ploop, which is same as block device, but with lots of bells and whistles. Basically, it's a modular design. You have the lower level, which is image format. It's upper level, the image format. You can do things like QCOW, or other formats, or you can have the plain format. And then on the bottom level, you have various I/O backends. So you can write on the local file system, or you can write to NFS in a very efficient way, or you can do something totally in the user space and have an I/O backend that combines this ploop file from whatever you have in there. And it supports online resize, both growing and shrinking, even if file system doesn't support it. We have some features like instant live snapshot and facilitate to make live migration faster, similar to ZFS, send and receive. So this ploop thing is only available in the OpenVZ kernel for now. We are now adding QCOW to backend support for it, and I hope that we'll be able to upstream this technology as well. That's pretty much it. Here is my email and Twitter account, and if you have some questions, please reach out. Do we have time for a couple of questions?
Sure, 5 minutes, absolutely.
Okay, fire up.
Oh,
Yeah.
Hi. So you did mention how the migration happens for the network stack. And so what are some of the big challenges that you faced in live operation when that kind of thing happens? And then you have a network being short out, so you're not able to reach the other side.
The biggest problem is TCP is pretty complicated. You probably know that it's like a state machine in the kernel, and you have to sort of copy all that state, recreate it, the existing connections being it accepted or in progress, you have to recreate it on a different system. And the way we implemented that in Creo is we use a special mode for the sockets. It's called repair mode. You put this TCP socket into repair mode, and then you call connect on that. Usually, if you call connect, that means the packets are going in and out, and you send SYN, the other guy send ACK, and so on. In this case, if your put socket in repair mode, you call connect, it just makes the socket like, it marks it as connected and doesn't do anything. So this is the way we recreate it. Also, if there is a network buffer which is not empty, you copy that buffer and you put it there, and if the socket is that repair state, it just puts the data in there, but it doesn't send it yet. So this is the way we copy the network buffers. It's pretty complicated, and I think we still haven't upstream migrating of the non-established TCP connection. But that happens very rarely. I mean, it's usually either established or not. And currently we have the patch, but it's not upstreamed yet. It's pretty complicated thing. I mean, for TCP, for UDP, it's a bit simpler. And the way we actually do live migration is when you freeze the container, you start dropping the packets. If it's UDP, it's okay. It's supposed to be. dropped sometimes. If it's TCP, the sending side will not get a ACK from us and it will resend. And once we have migrated, we send the ARP announce saying like, hey, this IP is now here. And the sending side will resend everything and we recreate it from there. So this is roughly the way it works. Okay.
And let's do that again. Wow. Better.
Thanks so much. Oh, any more questions?
No, no. Oh, you owe the hand. I saw it. No, no, no. He saw me at the front. Well, thank you very much, Kier. And I especially double thanks. Kier's a real trooper because he was also one of the last to leave yesterday. So it's amazing. So just a couple of announcements before we. What do we have now? I think coffee break or any? Let me just check. I think we have a quick coffee break now. Yeah. So don't forget before you go out. Don't forget. Open Spaces sessions is after the next talk, so now is the time to put up your stickies or vote on what's up there, but I don't think there's much up there. The nerd has asked us if people parked outside at the front.
I'm gonna use that one. That's all right, right? I'm gonna use this mic.
If you'd like, but as soon as you step away, it's not
I won't.
as well.
Yeah, I don't have
But
a
if you'd
remote or
like-
anything. So.
Plug it in and you can walk around
Well,
and wave your hands.
I don't have a remote, so I prefer
I
to
see.
stay here.
Makes sense.
That's what I like to do, anyways.
Sure,
I'm just
yeah.
checking that. Yeah, it's on, isn't it? Yeah, it is on.
Jared can hear us.
Cool.
Laser pointer.
Yeah, I'll use the mouse.
Play with lasers.
I'll use the mouse so it shows up everywhere. Turns out the whole conference has been a stream.
Right. Like, I checked this stream. It looked good.
Oh, Photoshop. Yeah. I'm actually going to the international. I got tickets. Yeah, I was like within like 3 seconds of it going live, I was like, yeah. Well, the thing is, when trying to book Airbnb, it was like, yeah, so this one. Not that he needs another one, but.
have a few minutes, but we might just start earlier.
Codeship, take it away.
Hey, all right. So, talk number 2, continuous delivery with containers. I'm Nick Gothier. I work at Codeship. We've got a booth out there. You can chat with Kurt if you want to talk about Codeship, and of course, you can always chat with me about it. We do continuous integration and delivery, and personally, testing has always been really important to me going back through my entire career, so it's something I'm really passionate about. So, bringing that forward into the new world of containers, we're going to talk about how to do that. With all this new great tech we've been playing around with so far the past 2 days. So I want to start off just talking about what continuous delivery is. Give a brief introduction so everybody knows what I'm talking about. If you've heard it before, that's all right. We're not going to spend too much time explaining it, but I want to make sure that we're all on the same page here. So I like this quote. Continuous delivery, CD, is a software engineering approach in which teams keep producing valuable software in short cycles and ensure that the software can be reliably released at any time. So I hope everyone can agree that one of their goals is to ship valuable software. I'm just going to gloss over that one. Short cycles, that means you want to be shipping early, shipping often, shipping as quickly as you can, and having that, okay, I have something cool, let's get this to our users, and okay, now our users can see that cool thing. Have that cycle be as small as possible. And then reliably released at any time just means don't break the build. You have to know that whatever is in this particular place in your code, SCM or infrastructure, if it's there, it's okay to ship. And you want to keep that, make that be something that can be continuously updated. So this really means like don't break the build, keep master green, or use a production branch that's going to be green. So that you know that you can ship that at any time. You don't need to like ask everybody on your team, hey, can we actually deploy this? Is that okay? Is something going to break? So that's really all continuous delivery is. It just means you're always shipping. We actually have t-shirts out there that say always keep shipping. You can put one on and then you're continuously delivering our slogans. So what are our needs for a continuous delivery system? So the core attributes, at least the ones that I think about, are speed, parity, reliability, and flexibility. So what does that mean? For speed, for that CD cycle, that means that once you say, all right, I've got this stuff up on GitHub that I really like, let's get it to users, we got to check that code out. We want to run the tests or run the build or both, compile, build that deployment artifact, ship it somewhere, and then start it and actually boot it up. So what do I mean by deployment artifact? This can be a lot of different things depending on what you're doing in production, what you're doing with your local code base. It can be a binary, it can be a slug like Heroku uses, this could be a WAR file, it could be a VM, this could be like an AMI image, a container, a tarball, whatever it happens to be that you actually ship. So when it comes to parity, for me, this is like, it worked for me, like it worked on dev, the tests pass, we shipped it, now it doesn't work, like that's parity. Is it actually going to work the same way in all of the places that you're using it? And then reliability, let's just try running it again. Maybe it'll work the second time. We want to be able to run things each time, have them be working the same way over and over and over. So if on our local machines it passes, that means that it should be passing on CI, and if CI fails and you just run it again, then it passes, then you don't really have a reliable system. If you have to deploy a couple of times before it goes through, you don't really have good reliability there. And then flexibility is, I need X. Like, what happens when you need a new thing that you didn't need before? How hard is it to get that new thing in place throughout your entire pipeline? So what are the options for us to do continuous delivery? This was something we were looking at as we wanted to bring our application pipeline into this, really level up our operations. So if you look at past solutions, these are things like Elastic Beanstalk, Heroku, many others. They tend to be really fast because they've already sort of set everything up and built it all up for you. So you just sort of give them your code and they're really good. They have whole teams of people working on getting your code up and going quickly. The parity, though, isn't that great because when you're on your local machine, you don't like run your tests in Elastic Beanstalk and run your development server in Elastic Beanstalk on your own machine. At least if you did, and you went out to the cloud, that would be kind of painful. So it's kind of hard if something fails on a pass to bring it back down and figure it out. For reliability, they are usually pretty good because they have a whole team of developers making sure that exact environment is working fairly well. And then flexibility, this one, like, you can get stuff into those different environments, but usually they don't do a great job because they have certain, like, here is the Ruby one, and here's the Go one, and here's the Java one. And to get more packages and more customization in there, you have to do a lot of legwork. So the next one is, like, configuration management. And when I'm talking about configuration management, what I specifically mean is when you boot up a pretty blank server, and then you use one of these technologies to bring that blank server to the point where it can run your code. So in that sense, it's not great on speed because if you bring up a blank server, you then have to install everything, and that's going to be take that same amount of time every time, no matter what. The parity isn't great unless you're actually using those tools on your own, development machine on your laptop, but you're not really going to use those on your laptop. So I gave this an X, but I would give it a check mark if you used virtualization technology locally and applied your configuration management tools to those virtualization technologies and then did your development in that virtual machine. So, but that's kind of a pain. Reliability, I gave it a check with a question mark because I felt like this kind of depends on you. How reliable are your apt-get commands? When is that Debian prompt going to come up and ask for some user input that you forgot to give it? Or when is your configuration file that you've put in there going to get out of sync with the operating system's version? So this is a lot of work, but you can do it well. And then flexibility, of course, that's why these things came about. They're great at flexibility because you get to set things up exactly how you want. So the next level up here is a virtual machine. And when I talk about a virtual machine, what I mean is that sort of full image snapshotting, like building an AMI on Amazon. So you might use a configuration management tool and create that snapshot. And then when you want to deploy it over and over again, you just launch your snapshot up. So in that sense, it's a lot more reliable because once you've got that snapshot working and you liked it, it's easier to create a new version of it. And you also have that parity as well because hopefully you can move that VM onto your local machine and run it in a virtualization technology. But the speed still isn't great. It's better, but it can still take like a couple of minutes to really bring up one of these new machines. Then we looked at containers, and they really, really fixed that speed problem in a lot of cases. And of course, this is why I'm actually here at an event called ContainerDays, because if I didn't put all the checks next to containers, I might as well just not even give this talk. And from containers, there's still a lot of options. And for us, when we were looking around, Docker just added another check to speed. So I broke the rules of the checks and the X's just for Docker. And we'll talk a little bit more about that in a little bit. So why are we going to choose Docker here? It's not just about that speed. It's about how it brings a lot of benefits to all of those attributes. So one thing Jerome talked about yesterday was the caching layers and how rebuilds can be very fast, because after you've run a step, if that same step is run again when you're running through a Docker file, it can use that layer on the file system and just reinvigorate it and move forwards. That's why you can pull down an operating system image pretty quickly and just run it and say, I'm going to start with Debian, and you don't have to spend like 15 minutes installing Debian. You can just pull it down and run it. If you do a package installation in the Docker file, anytime you go from Debian to that package in the same set of steps, Docker just flies through it and like fast forwards, just like Git would. I also think that Docker files are pretty great, and they've chosen to be very, very simple. They're completely flat. You can't use any logic constructs. And that, I think, also makes them very understandable. It's just this one script that you're going to look through, right? And it's a centralized place. You know you can go to the Docker file and see how a machine was provisioned. Now, of course, you can take this to another level, build your own tool, inject it into the Docker file, and then run a whole bunch of crazy scripts, and you can get rid of all of those wonderful attributes. But most of the time, you don't need to do that if you've got something pretty simple that you're going to set up. So we really liked how with a Docker file, you got this sort of versioned history that was very clear to read through. Even someone who's relatively new to ops and development can look at a Docker file and go, oh, it's just like running these commands and setting these variables. That's great. Docker also brings a lot of official and community images, so you don't have to reinvent the wheel. You can say, you know what, just give me Ruby, and it feels just like a pass. They have these on-build images for languages. If you use like Ruby on build or Go on build, you don't have to actually type anything in your Docker file. It will look at your current directory, assume it's a standard Ruby or Go project, include the source code in, and run the standard language commands. And if you have a pretty standard project, then you don't have to do any customization. And that's really cool. And then the great thing about Docker is you can take these images and you can actually read their Docker files, and you can extend them, you can copy paste them, and you can tweak them. So you don't have to reinvent the wheel if you're doing something similar to what others have done. But of course you can, because you can start from bare operating system images or even from your own tar snapshots and build upon them. The other great thing about Docker is all the hosting choices. Everybody is jumping in the game on Docker here. AWS, Google, even Microsoft, which is pretty cool. There's really low lock-in here, because if you've Dockerized your application and your services, you can take those to different hosting providers, and you have to tweak your deployment scripts, but you don't have to tweak your application run environment and configuration. So that's pretty cool. And it's also, Docker's making it easier and easier every time to do this yourself. Things like Docker Swarm, Docker Machine are maturing and making this a lot easier. And there's also plenty of open source hosting choices like Deis, for example, where you can run your own Deis cluster and on your own machines, and then that creates a Docker environment for you to play around with. So that brings us to Docker continuous delivery. So I wanted to look at what our options are for doing something like this. So the first thing you can do to be delivering constantly is to do this off of your local machine. This is pretty much what everybody does when there's only one developer, or maybe a few developers that have really good communication between them. On my own laptop, I'm going to run my tests, I'm going to do my builds, I'm going to push my images, trigger my host pull. I'm just sort of doing it right here, and I can monitor it and tweak it and do what I need to do. And if something bad happens, I can just type a lot, and then that fixes things usually. But the problem is that, like, you know, hopefully you ran the tests. Maybe there's somebody who's, you know, no, not you, but like somebody else on your team who maybe just didn't run the test that time because they really needed to deploy something, and maybe they broke a bunch of stuff. And is it really that same environment? Because maybe you decided, I'm just going to run the tests on my local box instead of running them inside of Docker, and I'm going to say, oh, that's close enough. Building images, I mean, I don't know about you, but I kind of like thin laptops, and thin laptops are slow. CPU, the network, I mean, if you're on Wi-Fi at some co-working space, how long is that going to take? Pushing and triggering the host pulls to do the deployments. that can have race conditions with the other devs on your team. So you gotta really be communicating about that stuff, because you could push, then they could push, but then they deploy and then you deploy, and who knows what's happening at that point. So then the next option is doing a hosted solution for continuous delivery. So you'll build your CI container, and then inside that CI container you can run your tests, and now you know that your tests are going to run in that nice environment. Build your production containers, push them, trigger that host pull. And by doing it on a hosted environment, all of your team members can go and look there, and the host will sort of serialize all of your work so that you can all know on the team what's happening. But there are some issues right now with hosted solutions out there. Caching is certainly an issue. Caching all of those Docker layers. If those layers aren't around from your last build, you got to start all over again, and that throws all of those check marks for speed for Docker right out the window, and it puts you pretty much on the same level of configuration management tool. When you're running your tests in a CI container, it's up to you to make sure that that CI container is actually has good parity with your production containers. So that's on you, but you sort of have to figure it out. And then for building the production containers, it still can be kind of tricky to build your build artifacts and build your production containers, especially when you start building multiple of those containers and pushing them up and orchestrating them. And then the third option is to do a custom solution, build something yourself. But I mean, who knows what that is, how it works. It's all on you at that point, and it's up to you to build it completely awesome. And usually people go with things like Jenkins or Drone here, but at that point, it's on you, right? So what are we missing across all of these solutions? Docker's a new technology, so for us, we really wanted to look at what do we really need in this space to do a really great job? What would we need to do the best job for Docker continuous delivery? So to have a centralized continuous delivery system, we had to think about our goals again. Think about those original goals, but also what do we want to be able to do with Docker to be able to have the best centralized system that we can. So that first one again is parity. So at this point, we're going to stop pontificating a little bit, and I'm going to talk about a couple of ideas that really helped us out here, and hopefully can help you too. So for parity, that just means you want your CI container to be as close as possible to your production container. In reality, you can try to get as close as possible. You're never really going to get exactly there because you're not going to want them to be exactly the same. You're going to want certain libraries for testing, maybe different libraries for production, but you always want to get as close as possible there. So having the same from in your Docker file can really help here. Having them both come from the same Ruby version image, as opposed to the production one being this like CentOS image where you manually compile the Ruby patch level that you want with some patches. If you're going to do that in production, use that base in your tests as well. You can even have, you can even chain these and say, this is my production image, and my CI image comes from the production image, plus here's some test packages that we needed to compile some extensions or whatever that is. The other thing is you really want to use all of the Docker linked services. That's also sort of how Docker Compose works. We'll talk about that a little bit more. But when you're building your containers, when you go out to production, even with like non-containerized PaaS solutions, your services communicate over the network. They communicate with ports and environment configuration. So you're going to talk to your to your database over an IP, over a port. When it comes to CI, you don't want to then just make one big monolithic container that has a database inside of it. That's not representative to how your production system works. You want to actually do that over the network, and then you'll discover potential issues that could arise from doing it over the network versus having it all contained therein. And you also want your hosting stack to be Docker. So this is like our goal here. Like we actually want to take these containers and go to a Docker deployment mechanism. We don't just want to use Docker for CI to give us a good CI environment. We have to go to Docker too. Otherwise, we're not going to see those same situations or not have that same kind of control. So our next goal with this is the orchestration around all of our containers, how that's going to work in continuous integration, how that's going to work during deployment and in production. So that means running tasks and linking services. So Docker Compose is really good at bringing up all of your servers. But we also, in CI, we have to run a bunch of commands, and we have to run those commands with all of our other services connected to it. We need our database, we need our cache, etc. That's where Docker Compose's run comes in. It actually lets you run individual tasks instead of just saying, give me like a service, you can run a command as well. But that brings us to like multiple compositions. We may have a lot of different setups and environments for different kinds of tests. So for our unit tests, we might want to keep them quick and just run a small layer. But maybe integration tests, we need a particular service to work with. And then acceptance tests, we want to totally wrap up and black box our environment. And yeah, I'm leaving that as an open question that we'll work on later. And then speed. Clearly, this is one of the big goals from the start. It's one of the main reasons people are looking at containers now is to work on that speed, work on that continuous delivery cycle. And a lot of this is going to come down to caching. So for speed and caching, the base images are really important. We want to be able to use the layers from last time as well. So, sharing that base, layering on top, using those cache layers really helps us towards speed. So for layers from last time, Docker does this in a really natural way with registries. If you push your image up to a registry, it doesn't take that image, make one big blob of it, and send it to the registry. It takes all the layers that you use to create that image and sends all the layers to the registry as well. And when you pull it back down, that's why when you do a Docker pull, you see tons and tons and tons of progress bars, because all the layers are coming back down at the same time. So registries are a really natural fit for doing your caching. And then another one of our goals was parallelism. Whenever you get to a bigger project, everything starts to slow down, and being able to do things in parallel really can help speed it up. But it's really hard. But we have Docker isolation. And this is the same thing that you have from virtual machines, and containers bring that same thing. By isolating your different applications, by hiding which ports they're running on, remapping them, all that stuff, you can create really nicely isolated systems that are much, much easier to run in parallel. The trick then becomes the orchestration of all of that work. And that's because you have to orchestrate your orchestration. So if you're running things in parallel, but those parallel things are each using something like Docker Compose, then you need a Docker Compose composer. And that's where it all gets really fun. Orchestration of orchestration.
I think it's the marketing opportunity.
Yeah, right. I don't know. Maybe we'll just trademark it. This will be orchestration by Codeship. It'll be the name of our new product. It's a good idea. Thank you. So for parallelism, we might have a lot of crazy pipelines. We want to do that checkout, but then maybe we have a static analysis layer where we want to lint, do some style checking, security checking. Then when we go into our CI, we might have a couple of different builds we need to do to build up our container environment. So for our unit, we might be building version A for our unit layer. That could be really lightweight, run really fast. B for our integration tests, those could be different for each of the different tests as well. And then C was for like acceptance testing where we might have to black box it. Then we have to bring all that back together when they've all passed. If they pass, we want to continue to continuous deployment. And that's when we're going to have to potentially build multiple production containers and push those and deploy them together. And then if we bring all that back together and everything happens to work, then we deployed. And this can get pretty complicated. So even then, this is what I was talking about with the orchestration of orchestration, which is that the acceptance object, that one piece of that whole pipeline may be an application with the test environment in it that links to some other API that we use, plus a database and a cache. So we've got a lot of layers here. So of course, we have to go build that now because it doesn't exist. So this is the section where I'm really going to talk about what we learned, which means what we were trying to build it, and the assumptions we made that weren't true and had to overcome. So the first thing that you have to do when you're setting up this sort of pipeline is you have to define all of your containers. So that's sort of step one. That's what a lot of the workshops are here that you're going to be working on. That's sort of what you go through when you set up, your first Docker container. You have to define them with those Docker files. And of course, like I mentioned before, the official language containers can help you a ton here. Even if they're not going to be your end game choice because they're not small enough or they're not specific enough, they're a great starting point because you don't have to relearn everything that those people learned to set it up. And like I said before, you can go to the registries, look at the Docker files, and you can copy them, you can pick them apart. So I would always say, use these if you can, because even if they're bigger, a little bit more complicated, they're going to be more reliable than something you built yourself because they've been around for a while and a lot of people are using them. The official language containers, they dictate the operating system because they control that initial from. You can't say, I want the Ruby one that's on Ubuntu, not the Ruby one that's on Debian, unless somebody has also made that version. But the official ones, they usually are coming from Debian, and you usually don't get to choose there. So you can't use the official Ruby container that uses CentOS. And the other downside with these, like I was saying before, is that they're big. So that pull can be particularly slow over the network. It also can use a lot of disk space. When you're using Docker Machine virtualized, you have to manage your virtual disk space and how it shares that space with your host operating system. And that can get pretty annoying, especially when in your dev cycle you're building things over and over, you're pulling different versions. You have to do a lot of cleanup here. So what we wanted to work on here first is our containers for the continuous integration part, for the testing part. And in this situation, your code changes a lot. That's where all the churn is. Every time you commit something, that means your code has changed. So those constant changes are going to be something that we want to get really right with our CI containers, because that's all CI does, is it just pulls the next version and builds it again. And the majority of the time for this is often the dependencies. It's all of the Ruby gems, or all of the packages from Maven that you have to pull down, or all of the things you have to go get and compile. And so that can be a really big pain, especially when you've got, you're working in a dynamic language that has a bunch of whatever your dependencies are that build against like C libraries and bindings. Like that can take a really long time. But the thing is, the dependencies really only change occasionally. They don't change every commit. They only change every now and then when you do an update. So this brings us to hack number one, which is layering your dependencies. So in a classic Docker file, what you're going to do is you're going to add the current directory. That means that everything in your project's directory is going to get put into the container. And when you do an add, Docker will create a layer based on those files. And I believe what they do is they use the modification times and hashes to determine whether those files are the same. So only if all of those files are the same will you be able to use a cached version of this add command. And then after that, you would first, no, it doesn't.
Does that change?
Yeah.
Oh, I'm very sorry.
yeah, and that's the thing why I'm not completely sure is because this is changing a lot. Originally, it always busted the cache. Then I think they did it with like file modification times, and then I think they started using like hashing functions. And honestly, I don't really know what the state of it is at this moment. I just know that this trick works, and that you can do caches on your ads if you're always adding the exact same stuff with no changes. So after you add all of your stuff, the next thing you usually do is you do your dependency management. This is your make dependencies, bundle, Maven, go get, all of that stuff. And then after that, your command for your CI container, whatever it is that runs your tests, will come afterwards. So if there's a small code change, you have to rerun this run command. With a layered setup, the first thing that you want to do is add whatever your dependency manifest object is. So in the Go world, this might be your GoDeps directory, and in and maybe your make file to do the building. In the Ruby world, it would be your gem file and your gemfile.lock. I believe you can do this with Maven too. It's like the POM XML or something. I don't exactly know. But you add in whatever it is that says, here are all my dependencies, your code. Then you can run your dependency building, bundling, etc. Then you can add everything, which will give you that secondary layer for your own code. And then you can run your tests. And then if you don't update your gem file, for example, with a new version of your gemfile.lock, you can reuse that layer, and you don't have to redo your dependency builds. For me, I always think of Nokogiri. For anyone who does Ruby development, that gem takes so long to build. So with this dependency layering, you want to cache on manifest files. And there were times when we didn't have a manifest file, but we could use scripts and language introspection tools to build a manifest file in order to preload some of this stuff. So like in the Go world, there's like some Go tools that let you scan your source code, and it tells you what all of the remote packages are that you're using. Then you can send those to the go get command and download them ahead of time. So even if you can't do a perfect job of like building everything, anything that you can prefetch, precompile, if you can jam that into another layer at the top, you can really speed this up. So this is really great on CI, but it is fantastic in development on your own machine, because when you're tweaking, like, okay, change that, add a little spacing, refresh the page, change that, refresh the page. If you have to rebuild your images, you want that to be insanely fast. Okay, so the next hack was registries for CI, because one of the things I was talking about before is that if your CI server doesn't actually have the layers from last time, it can't use the layers from last time. So for us, this meant that when you're going to be running those builds, you want to pull your application as it was built on the branch that you're working on from last time. By pulling it down, you are going to pull a little extra that you don't want, namely that final layer with your source code in it, but you also are going to get all the previous layers that went to build it. This is like priming your cache with the results from last time. And by doing this with a registry, you leave all that up to Docker. You don't have to like ship tarballs around and put them on S3 and take your .gem directory, you know, your gem home or your like your Go path or anything, zip it up and ship it around. If you just use registries natively, this will get you there much, much easier. And all that really means is you're going to pull it down before you run CI, and then push it after your CI is done. And you could even like background this after you do your builds or something like that and push it back in. You just want to tag these things with not production tags. So you can go ahead and add prefixes or suffixes or whatever makes sense for you, naming them so that you can keep those separate from what you're actually shipping. And then of course you want to run a registry near your CI. You can use the Docker Hub, but you don't have to. They've open sourced their registry tools. They're also launching, I think it's in the first beta or first RC of their new version of the registry. And there's other registries out there too, like Quay. There's even a really funny one called the Dogistry, like Dog, like the meme, that is a registry that you can put onto S3 and doesn't actually run a server. It's like a file store based registry system, which is pretty funny. So if you can put your registry near CI, that means that those pushes and pulls will be very, very quick. The last thing you want to do is be going like across coasts or countries to get to your data. And then for your production containers, you want to make these really close to CI. Again, this is not just about parity. In this case, it's actually about speed. The closer your production containers are to CI, the faster they will build because they can use layers from your CI containers. And of course, you can flip this around and say, if your CI containers are very close to your production ones, they can use the production containers build layers to build the CI containers. So keeping all of this stuff really close just has wins all around. So yeah, common bases, that's really useful. If you have like, you've got like API number 1 and it uses Ubuntu, and API number 2 and it uses Debian, and then our app, it's based off of CentOS, you're going to pull like 2 gigs just for that. So yeah, if they're huge, it can be slow to push, slow to pull, and slow to deploy. But if you've got a lot of layers, it can really speed that up. All right, so hack number 3. Now we're going to do some really fun stuff. And this is, somewhat, I'm not going to exactly recommend this. I just think it's really cool, and I always want to share crazy techniques just to get people's minds churning over this stuff. So this was something really neat that we worked on that sort of throws a couple of the pieces of advice from before away, but can also give you some benefits. So this is a trade-off. Exercise your brains. So during CI, one thing we might want to do is build a production binary off of our system. This could be like an actual binary, or this could be like a bytecode, something like that. And then we'll do a Docker build of our production Docker file in the current directory. And then we might just take a bare OS, maybe install a dynamic library we need, and then inject just the binary in and run it. So what that means is we need a minimal number of packages to install in the operating system. We don't need any language packages, or maybe we just need that VM like the JRE or something. But this only works for compiled languages, so it's only somewhat useful. And then there's a little addition here, and this is just crazy, and I suggest that you try this out at some point just because it's really fun and makes your brain hurt because it makes you think about how different containers are from VMs. Scratch, if you don't know, is a Docker container, and it's represented by an empty tarball. It is the null container from which all original containers come from, and it has nothing in it. So in this case, if you make your production binary and you build, you say from scratch, you add your binary and you run it. And that's it. There's actually nothing else in there. It's just your binary. So these are hilariously tiny. We're actually running in production a couple of Docker containers that are in single digits of megabytes. So 6 megs, 9 meg containers. It is just pretty funny. So this only works for statically compiled binaries. It also has the worst CI and production parity because unless you're running your tests with a statically compiled production binary with no debug symbols, you don't really have that parity. So again, like I said, this is throwing out some of the previous advice, but it's also really, really cool as an optimization. And it's near instant push, pull, boot, deploy. How fast does it take one Amazon machine to send 6 megs to another Amazon machine? It's like almost impossible to measure that, you know. But one thing that we can do that gets us sort of in between these techniques are minimal guests. So what do I mean by that? I mean you want a really bare OS. You don't need all of Debian or all of Ubuntu just to run some language code. That means you're going to have a minimal tool chain and really minimal packaging and maybe even some DIY packaging, you know, pulling down your own code. So these are really small containers, and this is really helpful for the dynamic crowd, you know, Ruby, Python, all that good stuff, JavaScript. So there's one promising project I wanted to point out, and this is the Alpine container project. It's based off of Alpine Linux, which isn't affiliated with the containerization of Alpine Linux, but it's a really small guest that you can use. So if you come from Alpine and then you use their APK package manager to install MySQL, you can actually have a MySQL client container that's only 16 megs. And that's pretty cool, and that's pretty small. And they have this package manager, but you know, it's not the most amazing package manager, but it's got plenty of good stuff in it. So I think this is just one example, and I'm hoping that one thing we're going to see in the next year are lots and lots of different options for these minimal containers. Because even Debian is like, I think it's around 180 or 200 megs or so, and Ubuntu is a little bit more than that. But I mean, Alpine's like 6 megs, and it actually has a package manager, so that's amazing. All right, so this is bringing us back around to that orchestration problem. So we're using, or at least we tried to use Docker Compose. And the way that you do this, and we'll talk about this more in some of the workshops, so I'm not going to go too crazy here, but you can define your application. Really, it's just another service. And you can link them together and link their ports. And then you can do things like, say, run my app with make test. And it will actually bring up Postgres and link it to your app to be able to run those together. But we did have a couple problems with this. One of them is specifying different Docker files. I'm not sure if they've actually improved that since we worked on it. You also can't really tell when services are running. Compose considers things running when their process starts, but not when they're actually available. There's an open issue on Docker for this, but like it's probably not solvable, because how do you really know if something is up and running? So maybe there'll be some sort of check back system, but they're working on it. We also don't really have good environment variable encryption management type stuff. You sort of have to do this yourself. And you really can only have one Docker compose file. So once you start composing composes, you either have to have one big crazy file with a lot of namespacing and stuff, or you got to break things apart into directories. So for us at least, what we're doing in the meantime is manually running and linking all of this stuff. So that means that we're going to run our Postgres, we're going to sleep for a magic number with a frowny face on it, and then we're going to run our app, run the make test, and then we have to observe that one's exit code and then kill Postgres. So this is still pretty tricky, but we're working on it. And then, of course, our good friend parallelism. So we have to run and link and actually namespace all of this stuff to be able to do it in parallel. And really, this comes down to having to run your own agent, split up the work, monitor all of the containers. Yeah, so this is the fun stuff, right? But we'll figure it out. We're working on it. Docker Swarm is also really cool here, because if we have this sort of system where we're working and using Docker's own tools, if we're using just Docker and we're using the Docker host, Swarm can make one host, make it look like one host when it's actually driving many machines. So if we can build CI and CD pipelines in parallel around this, it should be relatively easy to run lots and lots of machines and run our containers spread across all of them and be able to scale that up incredibly highly. All right, bringing us to deployment. So there's a couple of different ways we can actually do our deploy with Docker. The first one is you push your code to your hosting provider and they build up the images. This is how one way of using Elastic Beanstalk works. This is how Deis can work as well, and there's a couple others that work that way too. The second one is you build and push your image like to a registry, and then you tell your hosting provider to pull it and run it. And Elastic Beanstalk can run in this mode. Elastic Container Service, Google App Engine, they work like that as well. And then you can also build up your Docker containers, but then cross-build them for your host's specific platform and push. And this is like what Heroku's beta Docker release does. It turns images into slugs. So if you're building on the host, that takes the burden off of CI, because CI can just push your code up and let the host build it. But that means, for the most part, with most hosting providers, these have to be single Docker file applications. You have to be able to deploy them on their own, because once you send it to your host, it's going to go. They're not going to be able to use your local cache, so it's not really as good. If you're going to build and push those images and trigger a pull, then you can use your local cache. CI is going to have to do your production builds, but that means that CI can also make sure that everything builds before anything gets pushed. But it does mean that push-pull can add some time, because you have to ship all of that over to the host, as opposed to just sending a little bit that's your code and having it build it over there. But you can push a lot and launch a lot. The build and cross-build stuff, this is all very new. You really have to look into how each one is individually doing it. There might be some really interesting stuff here, but it also makes me wary because it's not really using things in a natural way. It seems like it's more of a shoehorn approach. But it could give you a nice blend of PaaS and DIY pros and cons. So fourth hack here is to, well, use the same registry. So if you've got your registry near CI, you can push your CI layers to the registry, just like we did before for our own caching, but now you can tag them for production. And that means that when you're actually pushing for production, only a few small changed layers are going to get pushed up. And then you put your registry near your hosting provider as well. So when they pull, they only need to pull what was changed since last time. And if they do have to pull everything because they don't cache, at least it's very close by and the pull will be fast. So you want to keep those common bases in your registries. You want to use similar bases and keep them all close together. And for us, this meant Amazon all the things. But you can replace Amazon with whatever your cloud provider is. All right, so what's next for us? Where are we still going here? What's unsolved? Better parallel tooling, clearly. Docker Compose is good at building a development environment. It's good at running tasks, but it doesn't quite have that ultra abstraction layer to let us do a lot of things at the same time. And maybe that's not Compose's job, but it would be cool to see more things in this space. Better development environments, being able to do a better job like syncing your code sort of hot when you're running your containers so that you can really be moving quickly. If we can get people to actually write code constantly by using containers, that'll give us the best parity from your development machine across your entire pipeline. And then better machine provisioning. So Docker machine right now is a CLI, but it's not a library yet, which means it's kind of hard to automate because you've got to shell out to it. But being able to orchestrate your physical machines or physical VPSs through the same tools that you use in CI and in development means you're going to get that host level parity across the entire system. So that's something else we're also really looking at. Okay, so that brings me to the thing that I have to do, which is plug our awesome private beta. We're doing some really crazy Docker stuff with CI and CD. We solved a lot of these problems for ourselves for CI and CD, and then it's becoming part of our new product. And we've got some crazy things that mostly work that are cool to mess around with. So if you're interested in really pushing some of this stuff, you can chat with me or visit our booth and chat with Kurt. Okay, thank you. My timer just said 45, so I'm sorry I had to rush the end a little bit to get there. Are we okay to do any questions? Okay, yeah. Awesome.
Hi.
Cool. Well, I hope it's because I explained everything perfectly, not because everyone wants to go eat lunch.
That's cheating.
Some people talk about at the end of your build pipeline, you should squash your image so that it's only one giant image, because then you know you have the same thing as the build artifact. It seems that your opinion is the opposite of that because you want to take advantage of the layers and speed. Can you talk a bit about that?
Yeah, so I mean, I think this just comes down to another trade-off that you're going to have to choose between. If you have a lot of complicated setup that's going to yield a large image through a lot of steps, then the layers are going to be really helpful because you can use as much of the, and that's going to work if your hosting provider can also make use of those layers and pull and is caching. So some hosts can and some hosts can't. So if your host can't pull off of your layers, then squashing makes a lot of sense because you want to ship the smallest individual thing over there, not all of the intermediate layers. So those hosts, that might be a better solution. If you're running something that's more like DIY, where you're going to pull from something local and you can have that configuration ability, then the layers make more sense. And then there's also the crazy scratch containers where it doesn't really matter anymore when they're small. So, that answer?
Okay.
Cool.
Yeah, and I mean, just as a personal thing, my talk, so I don't want to jump in too much, but it depends also on the frequency on which you're doing something. Shipping a big fat monolithic thing, what we've had like that works if the frequency in which you're trying to update them is low compared to application scale. If you're trying to commit, if you're doing a build once a commit or something like that, as you do in CI, if you're committing every couple of minutes, maybe shipping hundreds of megabytes every couple of minutes is not exactly a particularly a lot of pipe to make that work.
Yeah, there's a particular tipping point when your dev cycle, like your CD cycle, actually takes longer than when your builds come through in your source control, right? And that's when you go into like CD debt, when you're committing stuff faster than you can actually ship it, So as long as you can avoid that like swapping of CD land, then you're in a good spot. And I had a chat with somebody who was like, oh, I can just use Docker volumes and I can put all my dependencies on the volumes and I can ship them around. And then why stop there? I'm going to put like packages in there and then I'm going to put my code in there. And then it's like, well, if you're just using volumes, you're just doing VMs. Like it's the same stuff. You're going to want to use configuration management tools, use persistent volumes, and you're not really taking advantage of the immutability and repeatability that Docker is bringing. So if you want to go into the Docker world, you just got to embrace it and all of its benefits and all of its flaws. Otherwise, you're just going to be keeping a lot of the downsides of what we've been doing before, and trying to jam them into this new style.
One of your optimizations was to use Docker Alpine, which is really cool. Did you guys look at BusyBox, and can you compare the two?
Yeah, so Alpine's got a package manager and a bunch of built-in packages, and we don't actually use it. I've just played around with it. That's why I put it in there as like a interesting project to watch. And I think it's an interesting pattern to watch too. Just that style of having minimal OS but with package management, especially if it allowed you to do your own packaging in a neat way, so that you could have, like, across your organization, you could maintain a couple packages, but then a lot of different teams could reuse those packages, that sort of thing. The BusyBox container just has the BusyBox tools in it, so you still are going to have to like do a lot of wget, compile, tar-based installation of stuff, which lets you do it on your own.
If you have wget.
Yeah, right. Because you don't. Yeah, I meant the
Curl.
No, add URLs.
Oh.
Docker, you
But
can
that's
say
but that's
add.
precisely why Alpine is. It seems like easier choice there because
Yeah, right,
well you're
right,
like,
right.
oh, I don't have wget, no problem, just app
Yeah,
install.
because in your Docker file, when you say add, you can give a local path, but you can also give a URL that you can access, and that will do the wget or curl, but outside the container, then pop it into the container. So that kind of gets around that. But yeah, the BusyBox just gives you those tools, but it doesn't really give you an environment. I'm just hoping we see a whole lot more in that space, like all the way through lots of different styles. What would a minimal one that uses apt look like? That would be awesome. If there was like a minimal apt-based one that didn't have all of the base Debian software.
There is a BusyBox.
Yeah, he is a force of nature. Yeah, there's tons of cool stuff.
There we go. And on the force of nature note, we will end this. Thank you very much, Nick.
Thanks.
All right, we're a little behind. Who cares? I think we had.
Packages are particularly cool. The way they have the ability to, they make
actually have sound. Let's go ahead and get that. You can use either of these. Okay, that's fine. So we'll do that. I started.
Do you have Kevin's number?
Kevin's.
You both strange in the other room.
Okay, so let me explain, first of all, what we're doing and why. And hopefully it'll match with what you want to do and why you're in this room. We'll see. I like to tell people who ask me a question, like, hey, Dave, I have a question. I'm like, guess what? I've got an answer. Let's see if they match. Okay, so we did a workshop at Container Days Austin. It was last minute, and I definitely learned a few things myself. I was the one leading the workshop. One of the things I learned is that there are other people who know a lot more than I do, but that's why I wanted to do the workshop in the first place, is to learn a lot myself. And well, after talking about it with other folks, I started evangelizing this idea of how things might evolve from the standpoint of what we're actually going to end up doing with containers as developers, as IT folks, and what the whole process might look like. And it kind of changes what we do. I don't know if you've been looking or following along with this idea of pushing images around, but it does change a little bit about what you do as a developer, what you do from ops, and the process could be very disruptive. But it really depends on how much of that you want to embrace and what you're doing. So the idea of this workshop is to share with you some thoughts about that, get you started with Docker, let you see and experience how you create an image on your Docker or on your laptop using Docker. In this case, we're using boot to Docker. By the way, I heard that boot to Docker actually might get deprecated, and they might move over to Docker Machine as the actual tool for working with images on your laptop. And so apparently you can start with that now. I think it's available. I'm not sure if it's what they're promoting right now, but that might be what happens. This is all hearsay. I haven't gotten it from the horse's mouth yet. But so think about that as maybe a future way to manage your machine, your images and your containers on your laptop through the Docker Machine. And a little bit more on that is that within Docker, there's two concepts. There's really the Docker engine, okay, and there's the Docker machine, and those are two different things. And then of course there's the container concept itself, which is just baked into Linux, the Linux kernel. So there's these multiple concepts that you have to keep in mind, and we'll talk more about those as we go forward. But I just want to set the stage that it's not like Docker is the container. There's multiple components in there. All right. So before we get started, though, I again want to level set by saying we're expecting you don't know a whole lot, but we do need you to download and install boot to Docker in order to do this workshop. If you have questions about what we're doing, or if you want to tweet or something, here's our Twitter handles. That's my email address. Each one of the speakers will probably share their email address as well. But if you have any questions or you want to send me an email for like the slides or anything like that, go ahead and we'll get back to you. And then furthermore, I'm working on taking this workshop and evolving it into a sort of a community workshop. A lot of the work that's already gone into this has been done by Boyd over here, who you know. And he's got a couple great blog posts, which I hope you will promote in your introduction. Okay, really good, thorough blog posts on topics fairly close to this. So really good content that you should look at, and I hope to help contribute to his content moving forward. So if you're interested in this topic and you want to maybe follow along as we develop this workshop, email me and I'll send you links to wherever we end up putting the open source version of this workshop. Okay. All right, a couple things. Yeah.
John Willis was talking.
It's not an iPad. That would be very nice of us, but no, we're not giving away iPads.
What is going on? Somebody's talking. I think that was Andrew. Can you just quickly go and tell him not to turn off whatever his mic is? I think that sounded like Andrew, didn't it? No?
We have an expert in the room.
Oh, okay. I don't know who that was then. That's weird.
I'll look around.
Okay. That was very strange. Okay. So, what's that? Yeah. Could that have been like an echo from like this morning or something? I don't know. That was very strange. Okay. So yeah, and for those online who didn't hear Boyd, what he was saying is that our friend John Willis, who his company that he started called Socketplane is acquired by Docker, he's been creating a bunch of a series of intro to Docker videos, which he's posted on YouTube. And if you just search for intro to Docker on YouTube, you'll see John's videos there. They're pretty good. So in preparation for this, you want to make sure that you have Docker installed. Now, if you have a Linux box, you can install Docker directly onto Linux. If you don't, if you're Windows or Mac, you need to go to this URL, go to the installation section within that page, and find your OS, and click on the link to go to the download of the boot to Docker for your operating system. Another way to do it is just go to boot the number 2 docker.io, and that'll take you to the links as well. Now, you don't need this repo, but I just wanted, the original workshop that I was going to do today was based on a fork of this workshop from Harbor. I don't really know them very well, but I was looking around at different workshops, and that one's very simple and easy to follow if you're brand spanking new. It's a little too simple, but it's a really good one if you want to start and you don't know much at all. And I'm going to show you that briefly just because I want you to see what they do there, because maybe that's the right content for you, then you can go look at it. But after I do that, I'm going to hand this over to Boyd, and Boyd's going to walk you through the workshop that he's developed, which he has more experience with sort of practical steps, which I think you'll appreciate. But yeah, this is a good one to go to. Either one will work. It's the same workshop. And let me show you that. While I'm getting this ready, just to give you an overview of what we're going to do in this workshop, we've got myself, Boyd, and Barak? Barak. Yeah. Bear, like a bear. Barak, okay. And Boyd is going to do the boot to Docker, develop your container image on your laptop part. And then there's going to be we're not sure who's going to do this yet, but I think Boyd's going to do the push your container up onto the container repository that we chose, which is Quay, which is a product offered by CoreOS. And then Barak is going to take over from there and show you how to take that container image that has been deployed, or I'm sorry, not deployed, published, and show you how you would then push that out into production. In this case, I think it's actually going to be DigitalOcean. Is that right?
Yeah. So
okay.
I'm going to start with DigitalOcean. Build a 3-node CoreOS cluster, from the ground up. Deploy some containers on it, that sort of thing. And there's actually a code, so you can have your own single CoreOS box to follow along.
Yeah, and so okay, sorry.
Open season on questions about Cosmos and Rocket, all the things. I'll demo Rocket, I'll demo etcd, I'll demo Fleet, I'll demo. I don't think I can get Kubernetes up in a few minutes, but Kelsey Hightower can. He's also back. But.
So okay, I'm going to just give you a very, very brief overview of this workshop in case you find this one works better for you. Feel free to. It's pretty simple. What? Oh, okay, thanks. No better? Yeah. Okay, very good. All right. So what you would do in this one is you would go to the repo. If you know Git, you can pull it down. You don't really need Git to do this. You don't even have to clone it really to do this workshop, but it would help a little bit. And then once you have Docker boot to Docker installed on your laptop, you would do boot to Docker init and then boot to Docker up, and that would just those two commands, and then you're going to be ready to start running these commands. Okay, so it's pretty straightforward, pretty simple. So init kind of gets your environment set up, and then pull up will get boot to Docker. I'm sorry, did I do that? Say that right? Boot to Docker up, and then Docker init. Yeah, that's right. Boot to Docker init, and then boot to Docker up. Right, okay. So then that gets you here. Yeah, thank you. Okay, and I would do that for you, but I've already got it set up and running, so it's not going to be the same. Okay. And then as you go through this workshop, if you do this version, basically has 3 phases of the workshop. Here they are. Okay, where you learn the CLI basics, Docker file basics, and then if you get to the advanced part, it's more like patterns, like different ways you would set up your Docker containers. And I just wanted to share with you just overview of what this one does. A couple things that I learned by doing this workshop. Number one thing that's super simple that I learned is that when you run Docker, by default, if you run something like this, containers don't actually stay up and running. Maybe some of you already know that. But it's kind of an interesting concept that by default, a container that you run shuts down as soon as you finish running it. So this would literally output onto your screen, hello world, and then shut down the container. And then, and that's how the default behavior of a Docker container works. And then what you can do, if you want to keep it up and running, is you can put in the parameters I and T. Okay, and what happens is that keeps standard in open. Okay, and then also, I forget what that stands for, but it's sudo TTY. What does the TTY stand for again?
Terminal, essentially.
Basically terminal, right? So it keeps your terminal open so you can interact with it, okay? And that's how you might interact with your, keep it up and running so you can keep interacting with it. All right, and I'm gonna hand this over to Boyd soon, so Boyd, get ready. You can do some really interesting things with your containers. Here you can run a command, have the output of it passed into the next command, so you can pipe your commands, which is kind of cool. Probably the most practical thing is that when you run a container, you probably, if you're building a website, you need some way of actually testing your web page in that container. Containers by default don't get IP addresses. So how are you going to go and test your website? So what you would do then is you'd have the local host of your machine is your IP address. Okay, so you can use localhost or the actual IP address of your machine, of your laptop. And then you're going to expose a port, which the port will then connect into that container. And so that's how you get access to your the website running inside of your container. Okay, so you'd run, and this is how a -p exposes the port, and then this actually runs nginx inside the container. All right. Now this command here, you have to install the binary or whatever it is for Chrome in order to actually use that. But what it's going to do is it's going to actually run Chrome behind the scenes, like in memory, and then output the results into your terminal. That's what this actually does right here, I think, if I understand correctly. I actually didn't install this myself, but I think, doesn't that actually output the results? You can also do curl. Yeah, you can do curl too. It's another way to do it. I think they're. Does it actually open the browser? I couldn't get it to actually. Okay, right through command. You're in your terminal. You type that, and it's literally gonna open up there. Okay, all right. I didn't actually install that, so I didn't get to test that, but Okay, and then the D right here helps you run the container in detached mode, which is actually more like you would do, I think, in like a production environment. So the dash I and the dash, was it P? Or T, I'm sorry, T. This is not actually how you would run it if you're trying to keep your website up and running. Just, again, what I learned the hard way. So I'm kind of just giving you a very, very brief intro to this workshop. I found this is like a super easy one to go and follow yourself. You can type the commands. They would generally work. I didn't have any problems with that. I just had problems just understanding what it was trying to do. Later on in the workshop, it talks about how you attach a volume. So basically, how do you attach to some storage on your physical laptop so the container has access to files on your laptop. And you can do that here by attaching a volume. Okay, and then finally, they give you a little workshop to do. Okay, the next workshop or the phase of this workshop is teaching about Docker file basics. I'm going to go ahead and hand over to Boyd at this point so he can go through and show you that. But again, I just want to let you know that this is an option for you if you want to go and follow this version. I thought it was a very good simple version, but you can get through it pretty fast. And we wanted to do a little bit more, and I really like the way Boyd teaches the same subject. So we're going to switch from this version, which I would have taught, to what Boyd is going to show you. And believe me, it'll be better than what I had done. Okay. So, all right. Well, with that, Boyd, are you ready to switch over?
I am.
Okay. All right. Yeah, cool. Excellent.
All right, I suck. Dave just wants you guys to know that I suck, which is why I'm up here. All right. First things first, you want to grab something or write something down or type something out. The first thing you should do, because you're here at a Docker 101 class, go buy James Turnbull's book, The Docker Book. Period. End of story. It is a great book. For somebody like me who is familiar with Docker and had been using it a bit, it consolidated a pile of knowledge that I already had and filled in a whole bunch of gaps for me, okay? If you're just getting started, speaking as somebody who was once an educator, it'll give you a great start. And indeed, the blog posts are set up as learning experiences with homework and everything, and they refer to various chapters of the Docker book, of Turnbull's book, The Docker Book, okay? So a bit of background for those of you who weren't with me yesterday. This series of blog posts, and I'm going to prattle on so you can jot down those shorter URLs. This series of blog posts was born out of ContainerDays Austin. What happened was, you want it bigger?
Yeah.
Well, that's not awesome. I don't know what to do. Let's see. That was not what I wanted to do either. Damn Control Q. There we go. Is that better? That's not. There we go. Better?
That's good enough, yeah.
All right, cool. So when we had Container Days in Austin, we said, actually, Dave was like, hey, you should teach a Container 101 class on Friday day, because we didn't have stuff going on the day Friday.
This is for the online people. Oh, forgot to give it to you.
Thank you. Hello world. Yeah, see, it works with other technology as well. And now I can do this. I feel better. Okay, so what we did was we said, hey, we should have this Docker 101 class. So we did. And we said, we'll have 45 spaces. We'll do it for free. No, I understand. It's just not my nature. So stand still. I feel like I'm doing something bad already. All right, so we set this up. Dave was like, oh, I got this great curriculum and stuff. It was what he was showing you, and that worked out really well. So we had these 45 spaces that are gone in 3 hours, right? Then we had 62 people show up. Really? Right? You give something away for free, you're lucky if you get 2/3 of the people to show up. We had 2/3 more people show up. How awesome was that, right? So, I mean, talk about a nice problem to have. Check. All right, so
one of the realizations that we had from that was there was a lot of demand for the learning of Docker. And so what we decided to do at Docker Austin to follow up on that, as we were talking about at lunch, was we decided to do this Docker 101 sort of workshop-y like thing that these blog posts are. And I'll actually use one of them to guide us through what's going on now. So we use these to say, hey, the first 30 minutes of each Docker Austin are this workshop. And that means that our experts can they can come a little later, traffic, that last thing to do at work or whatever. And our noobs feel like they can come. And then the noobs stay for the higher end content, and they get infected, and life is good. We have viral, and viral is awesome. What was really cool, and really gratifying, and they told me that Thursday when I was flying here, that most of the experts were showing up right away anyway, because A, the food is really good, we have it catered, and B, they wanted to help out. They wanted to be able to answer questions and put their color on the answers that Paul Zarkowski, my partner in crime in this, and I are answering. So I may give an answer and I say, this is an opinion. I'll get somebody who's an expert in the audience say, yeah, but you could also think of it this way. So I want to encourage any of you who have experience with Docker, have opinions about how Docker works, to contradict me, okay? Or if I'm flat out wrong, tell me I'm wrong. All right, I will be wrong. Manny, raise your hand, has already commented twice on the blog post we're going to use and added some really nice things to it. I want to encourage you guys to do the same, please. All right, it's a community. Let's make it better. And that was power saving. See that? We're saving power for the community. All right, so we're going to build a Docker development environment. Why? Well, there are two reasons. One, it means that you walk out of here and you can play with Docker on your laptop anytime you want. And if you want to learn Docker, that's a great place to do it. You don't need to spin up a DigitalOcean machine. You don't need to ask your IT team for something to play on and wait 2 weeks. None of that. You just get to work. All right? But there's a real power in what I'm showing you, and that's the power in a disposable development environment. All right? I preach this. So imagine today that you have your hand-built, bespoke, artisanal development environment. It's beautiful. It's like a suit, except that when you pull in the string that is the version of Java, the whole freaking thing becomes unraveled. Now, imagine me naked for a minute. All right, yeah, so you don't want that to happen, right? That's bad. Yeah, no. Even my wife doesn't want that to happen. So, all right, so with that in mind, what do we need here? Okay, what we need is a way to upgrade Java, run all our tests, see that things work, and say, and then bless it. This is good. All right, well, I can do that with a disposable development environment. Instead of upgrading Java, all my dependencies, running my tests, going, shit, this doesn't work, and then spending 2 days crying, pulling out my hair, see it's happened, and rebuilding my development environment, I can just try this. Now, think about this for a minute from an innovation perspective. Today, without a disposable development environment, I won't upgrade Java, will I? I've got too much to do. The company's not paying me to upgrade Java. Hey, here's a nice new paycheck for you for upgrading Java. Go you. No, that doesn't happen. Yeah. Hey, here's 3 new features. Great way to go. Here's your paycheck. Yeah, that seems a little more likely, right? Okay, so I won't do it. It's too big a risk. Even worse, if I were to upgrade Java, find out that it was awesome, and then I can take all the new features of 8 and put them to good use for my company, the other 10 people on my team still have to go through it. And each one of their hand-built, bespoke, artisanal development environments is just slightly different. And each of them has to go through the hours and hours of time, pain, and headache of doing it themselves. With this, what David started you on with boot to Docker up. And when we're done now, we will have a development environment. And if you want to upgrade, in this case, Python, you just change the version number. And you say, go. And you run your tests. And you say, it's good. And then, when you want to share it to the other members of your team, you say, git push with the Docker file. And everybody says, git pull. And then they say, Docker rm-f, the container that they were working under, and Docker start the new container. And they are off to work. We're talking minutes. Minutes, right? And what about the not happy path? We always talk about the happy path. I'm trying to sell you Docker. Yeah, I don't work for Docker. So, no, I'm not doing that. What about the unhappy path? Let's say I try to upgrade Python, Java, whatever, and it fails. Well, again, oh my God, I gotta go put it back together. No, I just Docker rm-f, the trial, Docker run the old container, and bam, I am back to work. I have just enabled with this one thing Innovation. And innovation is the lifeblood of your company. Whether you know it or not, believe it or not, jump on the bandwagon, I'm right, get over it. No, not really. But read the Phoenix Project. That guy was really smart and, he wins. So with that in mind, let's get started, shall we? All right. Now, my understanding is the difference yesterday is I did a demonstration, and a bunch of you are in here. Today, I want to walk you through this step by step. This is going to go much slower, all right? If you're bored and you want to leave, you will not hurt my feeling. I only have one. It's hard to find, so don't worry about it, okay? So, yeah, and I'm sorry you're hearing all the same jokes because, I only have one of those too. Hey, that was a new one. Cool, go me. All right. So did everybody get a chance to jot those things down if they want them? All right, good deal. That just goes, no, I'm not going to save. Oh, it feels so good to do that. One less piece of clutter. If Docker could solve all my, file saving issues and tab stickiness, I would be so much better. It would be a much better product. Yeah, fix that, Docker. Thank you. All right, so each of these blog posts are 2,000 to 3,000 words. Sorry, I had a lot to say. I'm trying to motivate why you're doing these things instead of just what to do. So that's why you would do what I'm proposing here instead of going to Harbor. Okay, if you just want just a fax, ma'am, then go there. It's much better. So if you're already running Linux, you don't need to. You obviously don't need boot to Docker. So don't bother. So we've already tested the boot to Docker setup, but I want to make sure that you're there. So I'm going to stop mine. I think I need to make this bigger, don't I? And kind of give you an explanation of what's going on. All right. So by show of hands, who has boot to Docker installed? I love you people. So, all right. So if you have not yet, please type boot to Docker start, and I will make this bigger now. It helps if I do that, yeah. That was strangeness. Those hash signs are me pushing the wrong key. So what's happening right now is boot to Docker is starting the guest. Now, we're going to use a bit of lingo. This is my workstation, all right? So when I say workstation, I mean this actual laptop that I'm holding in my hand, not these microphones. Jesus. I get that I'm a nerd, but that was just pathetic. And it already says my variables are set correctly. Well, that stinks. I wish it hadn't. So I'm going to get rid of those sessions. I'm going to get rid of these sessions. Okay. Somebody say when. Terry, how are you back there? Good? So, all right. So I don't have a perspective for you guys over there, my Delians. Good? All right. Thanks. So, yeah, I guess I failed to mention that I was a high school teacher, so that's why I want to walk around and make sure y'all are behaving and stuff like that. It's weird for me to stand back here and trust you. All right, so let's say boot to Docker up. You already saw the dots and the zeros. The dots are the guest is coming up. What is the guest? Well, that whole, you were downloading a big pile of goo, that was VirtualBox coming down. VirtualBox is a hypervisor. Well, wait a minute, this is Docker, and we don't want hypervisors. That's the whole point, right? Well, it's one of the points if you want to drink that Kool-Aid. But really, what we need something to make this not a Mac. So we're going to put a Linux guest on our not a Mac or not a Windows. Isn't it weird? I bet Microsoft was really happy to just hear me say into their microphone that they're listening to not a Mac. Okay, I'll say it again, not a Mac. So when I say boot to Docker up, first gotcha. You have to export, or if you're on Windows, set these variables. So straight up, I am not a Windows user, haven't been for years and years, although that might change after what I've seen. So if I say something wrong about Windows or you have some color to add, please do. So what I've done is I've basically set those. Now, when I say Docker PS, that's basically a trust but verify. I now know that my guest is running and that command that's on my workstation, sorry people elsewhere, from here, this is my workstation prompt. Indeed, I'll never actually log into the guest. I will always interact with Docker through the bridge that they've set up. Okay? So I want to stop right there, and I want some eye contact, some acknowledgement that you guys are in good shape around being able to boot to Docker up and Docker PS. So I've got to know. So this is where I need my helpers. That would be Dave and Barrett, to help out. So Leah's having trouble. Is anybody else having trouble right now? No, everybody else is boot to Docker, has been able to Docker PS and see that they have no processes running.
Network connection was dropped because I went to run boot to Docker and it said, it's the first time it said, oh, have you run boot to Docker init?
This problem?
Yeah.
That sucks. Okay, so here, that's them rate limiting us. You don't have Docker installed, right?
I do have boot to Docker.
Yeah, but he needs a Docker init, which is that big ISO file.
That's not going to work. He's going to be stuck.
Shoot.
That's all right.
All right,
I'll watch.
Yeah, can you follow along? So I'm very sorry.
We'll share the video with you, okay?
And yeah, you can always go through the blog. I'm going to kind of do that as I go along here too. So I tend to, when I learn things, I tend to prefer blogs. When I want to grok something, I tend to prefer video. All right, so again, is anybody else having trouble? Everybody's been able to see Docker PS and nothing else. So, oops, helps if you don't click on that. Don't click on that. So this is, I'm just going through in the blog post right here. And there we go, trust but verify. That's a Russian proverb, by the way, trust but verify. It's also what all sysops people live by. So those Russians, man, they know how to drink some vodka and come up with some good proverbs. So, all right, let's develop. All right. So, because we have network issues that Lee ran into, sorry, man. One of the things that Dave asked me to do is not to use the Python base image. But because I have it on my machine, I want to show you a thing about building a container. And then we're actually going to go and do that a different way. So please don't try and build your container from the Python 2.7 image. Why? Because it's 750 megabytes. Right? And I don't think the nerd will appreciate that much. So we're not going to do that. But what I want to do is I want to have this opportunity, if you will. So I want to take it. So I'm going to move into my Docker Austin /01. You can go and download this. This is a GitHub repo, okay? So you can clone it, fork it, whatever. This one I'd encourage you to fork. I won't take pull requests on it unless you came up with something amazingly awesome that and if you did, please make a pull request and I'll accept it. So let's look at the Docker file here. So let's talk about this. Get that kind of up a little bit farther so everybody in the back can see. And again, sorry, remote people. What am I doing here? I am creating the first layer. I want to refer back to Nick's talk a lot from the Codeship because we were all here this morning. And that was a fantastic talk. So we've created our first layer of Python 2.7, and our first layer, all 750 megabytes of it, is fantastic. I think it's Ubuntu, and it's Python 2.7. Hey, look at that, the tag. And cool. Then what I do is I say everything in this directory, these files here, I'm going to mount to the containers /code directory, okay? So now, I'm sorry, I said mount. That's not right. I'm going to add those in. So I'm actually making a deep copy of these files from here into here. And if you're unfamiliar with the term deep copy, what I mean is that if I were to change this file, that would not be reflected based on this direction here. I'm making copies here to here, and nary the two shall meet again. They'll diverge, okay? Then I'm switching. Workdir says I'm now going to move to the code inside the container. I'm now going to move to /code, and I'm going to do work from there on. So that's another layer, okay? Then I'm going to use a Python construct, pip, it's their package management, and I'm going to install requirements.txt, which we'll look at in a moment. And then, last but not least, if I run this image, I want to turn it into a container, and I give it no other information, the command that it's going to execute is Python app.py, which is basically how I would run this natively on my Mac if I wanted to do that. So, is everybody happy so far? I get that not everybody's a Python developer, and actually knowing Python isn't a big deal here. The point is you could do this with Ruby or PHP. I don't know why you would. You could even do a Java and Go, although we can have this discussion later. When would you compile? So that's or Scala. So, yes, sir. Oh, I'm sorry. It's in the blog post. The repo that I cloned, is right there. Yep, docker-101.git. And then I put it into that I called that directory that thing there. But you can call it Fred if for all I care. Just know where you are. And then when you ls-l, you should see these files. I'm sorry, I was in presentation mode, not workshop mode. Thank you for backing me up there, Dave.
Yeah, just for those, if you guys don't know Git, probably just do a, probably in there, right?
Everybody's going to have, I think everybody's going to have Git on their machines from looking around. Is that a bad assumption? Yeah, but as I was walking around looking at what y'all were doing, I was peeking. It looked to me like none of you were going to have a problem there. If somebody is, please say now.
Yeah, it's the one that's exactly Git. All that,
Really, that's interesting because this should be a public repo. Let me check and make sure that.
too, so I'm not sure why you're getting that.
Are you using HTTPS or the SSH URL?
Switch to HTTPS, you shouldn't have a problem.
No, it's the other way around. Yeah, with SSH you shouldn't have the problem.
Oh, okay.
You're making a face at me like I'm wrong.
I must be logged in.
Roman, was I wrong? No, okay. I'm sorry?
It shouldn't matter.
It shouldn't, but I've had tons of trouble with HTTPS over the years, especially like when I'm using something like Chef or Puppet or.
Wait, so hold on a second. Okay. Which one is not working for you? Are you using HTTPS? Try the HTTPS one on this one. Just try it. It'd be the actual URL to that repo. It's exactly.
See what you got going here, Bill.
So that one didn't work, so I guess.
I'm not sure how. Oh, you know what?
I haven't converted it before. So. HTTPS work.
Okay, wow, that's.
Everything else, just.
All right, so HTTPS work. Yeah.
You know what that is? I wonder if we're gonna have port problems. I wonder if they've got S22 locked down.
I don't know.
So.
Yeah, use the HTTPS one, and then github.com/stacktin. Docker-101.
That's the URL. That would be how you'd construct the HTTPS URL. Okay, so you're good? I wonder if we're going to have a port 20. No, but Libby, you said you got it through port 22, didn't you? Okay. You good, Manny? Huh. Okay.
So just keep going, hopefully.
All right. So at this point, and again, I was in presentation mode, not workshop mode, so thanks for balking me, Dave. That was important. At this point, has everybody been able to see that they have those 4 files in their repo? All right, fantastic.
And just to make sure everyone, what are those 4 files? What 4 files should you be at this point?
Oh, okay.
I don't think I got the correct URL. I started with the first one.
I think you need forward slashes here.
All those, you can see them.
Fantastic. I like the easy problems, man. Give me more of those.
Overcome the first obstacle, and now we can
All right. I mentioned here, if you want to model a full workflow as a developer, you might want to fork and pull it. And again, don't concern yourself with the use of Python. So we were deconstructing the Docker file. All right. Let's get back to that. We should look at the Docker file. Do I still have it? Right there. Okay. So at this point, we were going to, I'm sorry, we did finish this. We were going to install requirements.txt, and then we were going to look, and then we talked about the command being what would be run if no other command is actually passed when we start the container. So let's look inside of requirements.txt. Man, that's exciting, isn't it? Look at that stuff. Yeah, baby. All right. So what am I doing here? Basically, this is telling Python, go get me the Flask library and go get me the Redis library. And so pip, the pip command is just going and getting those libraries from Python. Now again,
what does that actually say? Is that cat?
Yeah, cat.
My eyes are gone.
Yep, cat. All right, and then, so then let's look at app.py, cat app.py, just so we know what's going on in there. And again, there's no magic here. And when I did this yesterday, it's just kind of cool because I have a bit of a spelling error there. So we'll be able to fix that when we actually do our development on this thing. So all this is really doing is it's starting a Flask service, okay? And then it's starting. It's saying I have a Redis object so that I can write to the Redis so I can write to the Redis process that's in the Redis container. And then I'm running this particular code, which is to say I'm going to put that to the browser, and I'm going to go and get something from Redis that is actually going to tell me how many times I've been seen. So there's nothing sexy here, right? It's basic hello world with a little bit of dynamicism. All right. Excuse me. Now, this is the part I would like you not to do here, because we have these, I'm going to jump ahead a little bit. I want to build this application. So I'm going to say docker build -t. I want a tag for this. So let's say, what do I want to call this? Way too big. How's that sound? Colon latest. No, that's what I'm saying. Do not do this. If you do this, you will just bury the internet here. Not everywhere, just here. Now, I already have the Python 2.7 image on my machine, right? So, yeah. That's because I blew the cache with the add. We'll talk about that in a minute. So, remember what Nick, right? Yeah. Remember what Nick was saying about layers? Because I already have that Python layer on this machine, it's not going to go and get it again. That's pretty cool, right? I mean, that just saved me downloading 750 megabytes. I like that. I'm cool with that. I know. Why is it doing this other dumb stuff? Well, this is, I was the one who asked him the question about, hey, doesn't add always bust the cache? In this case, add busts the cache because it's a different file. It's a new file, so it's got to re-add it in, and that means that none of the other layers following are going to be the same. And so what happens is it has to recreate those layers. So also, it's running pip install, right? So it had to download those again, too, because it didn't know better. No, it does know better with, I think, apt and yum, but apparently with pip it didn't. So it's still downloading. Hurry up. Ugh. Okay. Yeah. It's you have much less fine-grained control. So you can say with the build right here, I'm saying Docker build, and then I'm giving it this tag. We can talk a bit about tagging in a little bit, but and then I could say --no-cache, and that would mean that it's going to build it from from the ground up, downloading everything again. Right. That can be a very good idea when you're doing development, because what Docker does, if you read the instructions, which I just did when Nick told me I was wrong about add, was what Docker does is for each command in the Docker file, it determines, except for add, it just checks to make sure that that line is the same. And then if it is, it assumes that it has the right layer. Does that make sense? So it's a matter of the layer before and the command following, command being one of these lines in the Docker file. And if that matches, then it goes and it says, okay, I've got that, and it doesn't try and download it again. Okay? So if you think about it, that's fairly weak, because you could, if I, like, for instance, I could add something to the requirements.txt, and if that were the case, it wouldn't know, and it wouldn't try and do it again. Okay? So that's is that actually a bug still, or? I guess it's documented, so therefore it is a feature. It's just but it is a gotcha, right? You do need to be aware of that. Roman, did you have a question? Okay, yeah, but it won't. But it wouldn't. But if I change requirements, this didn't change. This didn't change. Yes, you're right. It would have busted the cache here. Yeah. So. But if I took this out and ran it, so assume here for a moment that that's not there. Then back to your question for a moment. Then in this case, because this line didn't change, Docker is going to skip it. It's going to take what it had, the layer it had cached, because it's already been created. That's what's actually happening here. Oh, all right. Yes. Fair enough. But I don't have to add that to have the code inside the container. I could mount it as well. I didn't have how would requirements.txt even be? How would the build even be aware of requirements.txt? Because there was nothing inside the container to have that happen. So that was a great observation. I was trying to make a quick and dirty example. So thanks for cleaning me up. All right, we're still downloading. I'm not even sure what that is. Oh, you know what that is? That's I bet that's Redis. It's either Redis or Flask. That's big. No, that's not. That's too big to be those. All right. Anyway, let's There you go. All right. So one of Barrick's colleagues, Brian Harrington, is all about the tiny container. Yes. All right. And with good reason. I just checked with Jerome a moment ago. At Stack Engine, we had a 700 megabyte container that was our application, but basically it was just a Go binary. The reason this stupid thing was so big is we were building the Go binary in the container. That was a really good idea until it wasn't. And so I actually created a container that was 50x smaller, not 50% smaller, 50 times smaller. It turns out I was using half the memory and half the CPU when I was running the container. That was I actually thought, I learned that from using our software. And I was like, that's a bug. And so I started digging and digging and digging. I'm like, damn, that's not a bug. Why does that happen? So our supposition is that because you have that bigger container had a number of layers as build tools and stuff were installed, it takes a lot more CPU and memory for AUFS to go through those layers and do all of its copy on write magic. And so keep that in mind when you're doing things. Oh, please.
And a cool feature of Play is that you can actually download Splash.
Okay. Mm-hmm. Cool. Awesome. So Quay will actually squash the image at the end. And if you don't know what squash is basically I have something that's 50 layers and it just turns it into one. Docker squash is something Jason Wilder wrote, right? Yeah, I think it's a Jason Wilder thing. Basically what he wrote it for was he was creating images with hundreds of layers, but you have a limit of 127. So he would create 100 layers and then smush it, and then create 100 more layers and smush it until he got where he wanted to go. So these things can get pretty crazy. I have never seen that in the wild myself. So let's take a look here at what I'm doing here, and we'll build this and see how it comes out. So this is I need to create a new repo for this, so keep that in mind. The hell with that. You guys, create a new directory, go up a level, and then create a directory called foo or something, I don't care what. And then type that Docker file in. I'll wait. I'm workshopping. I keep going back to presentation mode, I'm sorry.
Hi, Oscar.
It's always the European guys. I haven't messed with that one. I'm really keen about Alpine. I've heard lots of good things about it. Yeah, because it has the package manager in it. So you can get a version of BusyBox with O-Package, but damn, O-Package seems to break all the time. So I'm going to switch to Alpine. That is what Brian would do, but I don't know. There's a part of me that likes package software. I want it to be easy. So give me some sort of nod, when you're all typed up. Thing's still working. It's really great. This is also a feature. If I Control-C out of this right now, it just goes to the background. It will continue to download. So it's not like I can get my network back unless I do evil stuff. So keep that in mind. That's why I was so, don't type this. If you were wondering why I'd gone psycho on you there for a minute, that was why. What's going to be cool here is some of you are going to have typos and bad things are going to happen. And let's face it, when do you really learn stuff? When bad things happen. The not happy path is the path of learning. I took the road more traveled. I taught math, not English. We're typing in this Docker file. This is the one you asked me to make that was smaller, so it was actually doable. Yes, because that's a different build context. Thank you for pointing that out. I was planning to have you guys copy those things over, but I really wanted it to fail first. So we'll actually fail it. We'll actually try and build, and it'll go right, and then we'll go, what happened, and we'll actually troubleshoot. Because let's face it, you guys will all go home and get it perfect the first time. I'll go home and not. So you have to suffer with me. So, no, I mean, let's face, when you're learning something, it's all about the why didn't that work like it worked in the blog or the video or whatever, right? So let's actually not have it work a few times and develop some problem-solving muscles along the way. I'm assuming this is what Dave was talking about, that I just screw up all the time and then sort of turn it into a learning opportunity. So. Cool. Is anybody still typing? All right. Cool. So let me talk a little bit about ODISE/busybox-python. All right. If it were just busybox, that would be a canonical Docker image. There are about 100 of them. Docker blesses them. Blessed. Okay. I have no idea on earth who this ODISE guy is. So I am absolutely certain there's some sort of keystroke capture thingy in there, and that he's probably got some spam bot stuffed in there too and all that crap, which is all to say that you have to develop a way of learning to trust certain things. In the same way that you'll find that really kick-ass GitHub repo and you want that library in your Scala, Java, Go, whatever, and you'll put it in there, okay? So, but don't trust things blindly because it's a container and they can put, all kinds of, really great stuff that. Yeah. Oh, geez, really? Hadn't thought of that. Absolutely. Yeah. Did you hear Barrick? Yeah. Don't ever forget when you're working with Docker, it's running as root. So that keystroke capture, yeah, it's running as root. So if that happened to be a privileged container, oh boy. What's up, Manny? Yes, indeed. If you go to the Docker Hub and search for that one, you can see the Docker file. How could it contain an Easter egg? Do you know all the packages that he put in there? Have you read all the code and every one of the things? Ultimately it boils down to the same thing as me trusting that when I went pip install Flask and Redis. It's the same trust thing that I have with Flask and Redis. It's just that I have a deeper trust relationship with the Python pip package manager than I do with some ODA ISE guy. That just looks like a hacker, right? It's only 5 letters. That's true. Well, I download those with the intent that I'm going to go and execute code. So I think you're walking a finer line there. So has everybody got that typed? Am I boring you to death? No. Okay. It's really hard for me to stand up here and not talk. Blah, 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 blah. All right. So let me show you what that clean build of the bigger container would have been like. Okay. All those downloads would have been complete. This is straight out of the blog post. It's static. And you can see that I get, some information, but for the most part, it's all nice and clean, right? This is good. This is what a healthy Docker build should look like. And one of the reasons is because I am using the Docker's Python, the canonical one. Notice it wasn't like bhempi hacker guy slash Python:27. It was just Python:27. It was a base image. Or was a blessed image, excuse me. So what if we want to build this? Well, Docker build. Then you please try this right there on your machine, -t. I am going to build this as what? My app. No, let's see. My small app : latest dot. Yes. Oh yeah. That's great. Yeah, Docker should fix that, huh? Since they're the ones saying you can trust it. Oh. Yeah, Python should fix that then. You're talking about this here, right? Yeah. I wonder what that does.
I wish downloaded a project and one of the files was sending to NSA.
Yeah, you gotta wonder if that's all right. So you guys should have something also icky, right? In fact, what you may is everybody getting this TLS error? I hope so. All right. Some of you, for me, remember that what I did was I started a new terminal session. Notice the tab. Okay, this is important. So this is the first script. So remember how we had to export those or set those environment variables earlier? That's what I'm running into with boot to Docker. So I'm just going to type boot to Docker up even though it's running. And it's going to remind me, hey, you're running, but you don't have your context yet. So now if I try to build, I'm at least going to get something sensible. So when I started that new terminal session, I didn't have those environment variables set. Does everybody kind of get what was going on there? That's a gotcha that had me waste 45 minutes going, why is it broken? I can see it running. All right. Oh, wait a minute. Wrong thing. That sucked. Why did that work so well? Oh, that's right. Phooey. I want to get the same error I think you guys are going to get. What happens when you pre-plan and then try to make things break? That's okay. Oh, sorry. It's all right. Yeah. So Docker build, I'm saying don't use any caching. Tag it as my small app : latest dot in this context. And I went and removed all of the app.py stuff so that I would get the same goofy stuff that you're going to get because, I'm sorry? Oh, shit. Okay. Well, first of all, let me make my point here. I decided I wanted to use BusyBox because now notice that BusyBox Python is only 20 meg, whereas way too big is 755 meg, and you can see Python here is 748 meg, all right? So my small app is only 24.79, 25 megabytes, and if I can find my app here somewhere, I might have deleted it. It's about, oh, I'm sorry. Yeah, it's the 755 megabyte one, all right? This is a significant difference in size, right? So as Nick was talking about, just moving these things around on the wire is a really, I mean, this alone is worth part of the headache. But it's a value judgment because I have all of this red. Now, I'm an operations guy, and ultimately I'm a DBA. And the first thing I want to do when I start Oracle or when I start MySQL or anything like that is I want to make sure the error log is clean. Indeed, I want to make sure all the logs are clean. I don't want warnings. I don't want errors. Red makes my eyes bleed. It's all bad news. I want this. So I've got to go back and I've got to track down all of this crap and make sure that things are good. Indeed, the reason that I didn't use pip is because pip is not installed in this image. And when I went to try and install pip, because I don't have all the root certificates in the image, BusyBox doesn't come with root certificates. Actually, neither does Ubuntu. It didn't work. Pip won't work without the root certificate. So I was going to have to either mount those to my machine, and since I'm running as root, that would be really dangerous, or I've got to go and solve the root certificate problem from the ground up in BusyBox itself. Okay? So all of this sounds like a lot of headache and a lot of learning. Okay, well, I like the learning. Is it worth the headache? Right? So I have to judge based on what I'm going to do with these images in my real world, whether I want to shrink them down to something this small or not. Okay, so that's what I mean when I say it's a value judgment. So all of that was to get you to the idea that, yes, you can make things smaller, and small generally comes at a cost of convenience as you have to figure out what's missing and put it in there bit by bit. And that's a very empirical thing. All right, so any questions about that? And did you get your thing to build? Why didn't it barf? I forget what my other Dellion's name is. Bill. Why didn't it barf like Bill suggested? No, I don't. And I don't think you do either. Well, so if you look here, I didn't add the specific file. I just said whatever the contents of the directory are, right? That's why the build didn't fail. So in the build context, in the configuration context, I'm good. Manny already pointed out what's going to happen when we try and run it. Yeah. So, all right. No, not at all. So what happened here was, I'm sorry. So add, right? Add just said whatever the current contents of the current directory are, copy those, deep copy those into /code in the container. Period. There's no runtime.
Exactly, but the line after that.
Oh.
Run when you're building the container.
Yes.
So it won't find anything there.
That's exactly right.
It's running something, but it sets up a future to some extent.
Yeah, that's exactly right. I'm sorry, Andrew. I thought you were talking about the add command. So so Docker calls each of those lines a command, and then they have a command, because Yeah, it's like orchestration, I guess, but better, or not. So, let's try and run this thing. Docker. I'm sorry, checkpoint. Has everybody been able to build this new container and all of its cool hotness? I'm sorry? All right, so you can just rerun that build command and just put the tag in there and you'll be fine. Okay, so anybody else having trouble? I'm sorry? Oh, let me get that back up there so if you're... do no cache, just to, although I don't think it should matter for you, but... All right, well then we need to take a look for you. What's up, Chris? Boot to Docker. Oh. Yep. So bring up that machine or start.
We even get issues trying to download the BusyBox.
Really? When you say getting issues, do you want should be able to just up arrow to the command.
Well, I restarted the whole session.
Oh, okay.
Because I didn't know what that was.
Docker build. You're not connected. That's a internet thing.
Well, thing is oh, that worked for me last time. Try .com.
So that's a DNS error. So Lee, that message you got that basically was that a DNS? Did it have a DNS message in it? Fantastic. All right. Has anybody gotten an error that says index.docker.io, no DNS servers? No? Getting an IO timeout?
Often, I mean, I've had to reconnect.
You know, so may I ask you to restart your internet?
Tried that already, but I can try it again.
Yeah, I'm sorry, I don't have a good idea for that. I've never seen that before. And maybe that's it, because that would explain why I couldn't find a DNS server. So
Yeah, I'm getting the IO timeout. I tried reconnecting, but
yeah, this is a conference Wi-Fi thing. I'm so sorry.
probably that's
So yeah, all right, thanks. You say no, Libby?
No, no, not good. But I had this like the doc.
By the way, it says app.py not found.
I'm sorry?
It says app.py.
Okay, good. Thanks for the preview. What's up, Libby?
Maybe I'm doing to the main.
I have played with doing that in Bash profile. Yeah, I agree.
Because it would have like.
I never dug into it further. I need to look into it, but yeah, I would love to be able to just say do that.
I have to do that every time.
Yeah, good idea, by the way. It's just I haven't been able to get it to work and didn't have the patience to go and dig in on it. Hey, are you in good shape then? Are you catching up? That was the so you're in the GitHub thing, right? So you want to use HTTPS? Google that. I haven't seen that before. That's a win. And honest to God, if you take a minute and when you figure that out and put it at the bottom of the blog post, that would be great for people. It's the first goo.gl that we had up on the screen earlier. All right, has everybody got a built image that I haven't kind of gone to and either helped you or said sorry to? Yes. Yeah, well, no, it's not. It is for our purposes. So again, today's question, is the red stuff okay? No. That's my opinion. It sucks. Don't do that. But there are no errors, so we can continue. All right? So if it were me, if I were building this for production, if I were building this for Stack Engine, like if I were building a container version of our product around this, I would go and figure out what every one of those things are, and I'd fix it. Right, that's because those those are all coming from easy install, and what's happening here is Python's not finding things that it wants to find. A really obvious example here is it can't find GCC, so it can't do some cool Jinja stuff to accelerate it, kind of thing. So I would, do I really want to go and put GCC in my container? That might drive me nuts. All right, so with that in mind, Docker run -d, all right, -p. We should have all kinds of bad things happen here. Let's see, what did I call it? My small app. All right, I'm going to try and run this container. So how is that working? What is this command going to do? Well, why did mine not fail?
What was that output?
No, I have a problem. It didn't. It's not running. All right, so Docker ps -a. All right, this is going to show me all the processes, so you can see that I've been doing a lot of stuff here. All right, now, if you do not give the container a name, it will give one for you. In this case, it's naughty. Haha, that's kind of funny. Mayor. So Docker logs naughty mayor. So I want to see what's going on. And hey, there it is. I can't find app.py. So I made a lot of assumptions here as a new user. Again, I'm modeling a behavior here. When I tried to run this thing naively, it looked like it ran, right? It didn't say, hey, bad things happened. It just said, oh, here's your container ID. Go. All right, now. Then I needed to, so trust but verify, right? Verify. Is there a running process? No, there wasn't. Okay, what processes are there? All of these. Here's the one I tried to run. It's called naughty mayor. So I'm going to go and look through the logs. And I find that, sure enough, we get the error that we were kind of anticipating all along, right? Okay, so just to recap the problem solving, when I try and start a container, the first thing I should do, until I'm confident in what I'm doing, is check and see that the container is actually running as I expect it to be. And if it is not, or even if it is, I should go and I should check the logs of that container. So when I was trying to containerize Minecraft, when I wrote the third blog post in this series around creating a container around a legacy application, Minecraft starts, and then on initialization, it takes about 10, 15 seconds for it to come up because it's writing out a bunch of data. Excuse me. So the container will look like it's running for about 15 seconds. So if you just trust and then verify, it looks like it's running, and then it hits an error like you didn't accept the EULA. So you're assuming the container is running when actually it's not anymore. Okay, so always, check PS, and then if something weird happened, make sure you check the logs. Don't forget your logs. Docker logs is your friend. All right, so, excuse me. Are we good for time?
Yeah, we got actually half an hour left.
All right, awesome. So what do we have? Well, really, remember, we need a Redis container running, don't we? So I'm going to kind of jump back over to the blog and sort of pick up where that left off. Or actually, I'm going to go back up to where we really want this to do. I want to run the Redis container. We have a problem. If you guys try to run the Redis container, you're going to download the Redis container, which is quite large. It's a couple hundred megabytes. I think that's going to crush us. So I'm going to ask you not to do that. I'll get you running the other one well, okay? And I'll show you, I'll demonstrate here what's going on, and then encourage you throughout the day to try things. I'm sorry, Dave, I forgot about that. We should have had people go and get that one. All right, I tried to run that container, and it failed. I suck. All right, Dave needs to take over. Oh, jeez. All right, so what happened? What happened? Again, we're not on the happy path here. Let's talk about Docker's naming of containers, because it's clever, but because it's clever, it can catch you off guard until you're used to it. So Docker run -d, I'm running this in detached mode. So if you're a developer, a lot of times your way of daemonizing something to see if it's working right is to log into something, SSH in, screen up, start it running, detach your screen, and let it go. That, running production, don't do that. I can't believe I still have to say that in 2015, but you have to say that in 2015. But for debugging things, for getting a whole pile of stuff into standard out that you might want to look at and so forth and so on, it's great. Don't stop doing that. But here, the detached mode does essentially the same thing for you. And anything going to standard out or standard error is also going into Docker logs. So if you've got your application writing the standard error and standard out, all that stuff is going to Docker logs and will go to the log file. All right, --name. Here's where our problem is. I specified the name of this thing as Redis. I said map port 6379, the common Redis port, on the host to port 6379, the common Redis port, on the container. Okay? And then I said run the Redis image. So this is the name of the image, kind of like we used my small app a moment ago. Okay? So notice it's telling me the name Redis is already in use by that container. Let's prove that really quick. Somebody has already told us about Docker ps-a, but we don't have any containers running, huh? Remember that some containers aren't running. And that's okay. Sometimes you want them to run, go away, and then run again later. And you can see that I have one right here. Well, here. Let's make this easier. How about pipe grep Redis? There we go. So that guy's name is Redis. So what I need to do is I need to remove him. All right, now if I try and start him, but is he running? Hey, he's running. Let's check and make sure that we understand what's going on here. Look, he's been up about 5 seconds. That's how much I was prattling on. We have the all interface on the host mapped to port 6379 are being mapped to 6379 on the container via the TCP protocol. The name of the image is Redis :latest. The name of the container is Redis. Its entry point is Redis. I'm sorry, it's running the command entry point.sh. So they scripted that. And that's a more advanced topic. We can talk about that at some other time. And it was created 6 seconds ago. All right, does all that kind of jive with what we're familiar with? Cool. All right. Note that if you say Docker ps-a, it will also show up because -a is all of them, whether they're running or not. All right. Questions, comments, or concerns? Now let's start our own real container. What happened? Entry point. We built our coolest thing. And now, here is our run command. So, I'm going to copy that. Mostly because I'm lazy and I'm afraid I'll type it wrong. Because I always get things right, have you noticed? That was sarcasm, yes. Yeah. Now, I want to deconstruct this command for you, okay? And then what I'm going to ask is that you find where it's going to fail, and we'll try it, and then we'll fix it and try it again, okay? So, Docker run. I am naming this command web. I'm sorry, I'm naming the container web. So when the container starts, it will be called web, not naughty somebody or another or foolish Fedorov or whatever. So I am mapping port 5000, that's just a port that I picked, there's no magic to it, on the host to port 5000 in the container. I'm mounting the volume, I'm making a volume. I'm saying that on my host, users Boyd, Docker Austin tutorial 01 should map to code in the container. So what this means is that the files that are in there are going to map to code there. And then Redis : Redis and my small app. All right, so here I'm creating a network link because they're on the same host. Docker has a construct for that. And it's basically saying, okay, you guys can talk now over the port that you specified, of the ports you've specified in these containers for my small app. So I'm going to try and run this. Let's see what happens. Well, anybody have any ideas about what's going to maybe potentially go wrong? It's going to be very subtle, by the way. I'm sorry? Go Manny. All right, so this path is goofy. If you think about it, we want to run what's in /cd boss, not in this guy here, right? That make sense? So I need to make sure that I am mounting the right directory, first of all. Very good. All right, so that's fixed. There's one other potential problem. Anybody know what it is? It relates to what happened with Redis a moment ago. I'm sorry? That's yeah, exactly. Potentially, I could already have a container called web since I'm specifying a name, right? Let's find out. Ah, well, I do. So docker rm web. And now I will say, I'm going to try again. I'm going to wait a minute so you guys can type all that out. Please remember that your absolute path will be different than mine. So obviously you won't be users Boyd. You'll be something else.
Right, but then
Yep. Because I tried to name the container web, there was already one called web, so it said, oh, no, you don't.
I got an error message that said URL is incorrect.
Sweet. All right.
Wait, hold on. What's? Oh, I see. I made a mistake.
Okay, cool. I'm going to press enter unless anybody has an objection. Is that what you were saying, Kent? It wasn't going to work because? No? All right. If we ls in here, I don't have anything called app.py, right? So for me, I'm going to copy /01/app.py here.
Another problem you could run into is you choose ports that's already being occupied.
Yes, yeah, that's exactly right. So if you already had something running on 5,000, that could be a problem for you. Now this will drive you berserk. Notice that I failed to start the container here, right? Then I checked some things, I made some changes, but even though the container failed to start, there is a stopped container. Oh, that's okay. And if you think that that's a distinction without a difference, you're absolutely wrong. The container did start, but because it's tied to the Python process, when the Python process said, "Oh, can't do that," that stopped the container as well. Thank you. That's a really important point that I've been glossing over every time I've done this. I appreciate that. Does everybody understand what Barrick is getting at? It's not the container, it's not Docker that did anything wrong or failed. Python is the thing inside the container that failed. And because PID1 is Python in the container, when it failed, the container said, I got nothing left to do, and stopped, like it should.
And just for clarification's sake, this
Thank you.
PID, by the way, is process ID, in case you didn't know. And when containers run, as I said earlier, they default to run and then shut down, unless you give them something to run that's supposed to continue running. Okay? Python can continue running and shut down, the container shut down. Is that correct? Why the container?
Yes, thank you.
Because the Python shut down, and therefore the whole thing shut down. So
Okay.
Further explanation.
No, that was great. Thank you. Does anybody else have something else to color in there? All right. I'm going to run this thing. Wait a minute. Something's wrong here. How come I didn't get my prompt back?
Running.
So somebody just said I didn't what? I didn't use -d. I didn't detach it, right? So did I do something wrong? No, I don't think so, because ultimately I want to debug now, right? I'm now in development mode. Why wouldn't I just leave this thing up and let the logs flow right in front of me instead of having to go Docker logs and fiddle with that? So I actually purposefully didn't run it with -d in this case. I wanted it to be in standard out. Does that make sense? So I made a choice there, and it's a reasonable choice. It's a choice you can choose to make or not make. It's up to you. I certainly wouldn't, if I were going to run this container in production as my application, I certainly wouldn't do that. But okay, thanks. I don't want you to lose your thunder on that one then. Okay, so. Okay, thank you. So you can see that we've seen this 1 time, right? That makes sense. That's the first time we've hit it. Now we've seen this 2 times, and 3, and 4. Well, that takes a long time. But I have this, all right, the anal person in me, which is most of me, just hates this. So I want to fix it. I'm going to fix it. And now this is where things get dicey. All right, so if I can kind of garner your attention for a minute. Let me do that up. All right, everybody understands that this prompt right here, I am on my workstation, right? I'm going to choose VI as my IDE of choice. Sorry to all you Emacs users, all the people who have used Visual Studio all those years and understand that it really is the best IDE in the world, and so forth and so on. Okay, but I have actually, I'm choosing to use VI. I mean, I am an ops guy, right? So, and I'm going to now go down and I'm going to fix line 10. Let's see. I changed that. I've saved it out, right? I have this hand here. I'm not doing any magic. I'm reloading. Shit happens. The entire runtime of my application is in the container. My ability to develop is still with all of my common and favorite tools on my workstation. I have a disposable development environment, except something. You're going to rain on my parade, aren't you? Now, what's up? Oh, I've essentially come to, so at this point, what I can do now is any changes I make to my application code are immediately reflected here, right? If I want to upgrade Python at this point, I can, if I were using the Python 2.7 base image, I can now say, I could just go and change the Docker file to say Python 3.4, and I would now have upgraded Python from 2.7 to 3.4. And then I can run my test in the normal way, go, cool, this works. And for all 15 of my colleagues, again, I just push, they pull, they run. We are now using 3.4. And a couple days down the line, if we find out, oh, crap, there's this one thing and we can't get around it, we can all go back in a matter of minutes as well. Okay? So we have just enabled ourselves and our team to innovate better and faster. We can take more risks because they are smaller risks. So it's Chris, right? Yeah, so what's up? The file? Okay, so you want me to, you want to look at, It did. So do you remember in the run command that I used -v, right? The fact that I mounted a volume over top of it. Right. That's exactly right. That was a brilliant question, Chris. Thank you. I'm sorry. I'm in the wrong one. Here we go. Correct. And indeed, if you remember, I didn't have a copy when I actually built the thing. app.py, the file, wasn't even in there yet, right? So, and I apologize again. I did this with, I really quickly turned this into a BusyBox thing so that we could all download it and play with it, right? So I want to stop here and ask before we break for a moment. Did everyone, was everyone able to run the container, run this container with that with that command.
Did you change inside the file? Did you change the IP address?
Inside the app file?
Yeah, since host equals 0.0.0.0.
No.
I'm not getting it to run for some reason. Yeah, see the bottom there? I guess you can do that.
Yeah, that means all interfaces.
Okay.
Yeah.
So for some reason
Okay, so is anybody else having a problem getting it to run? Okay. Oh, wow. Does anybody, so who's using, did you get it to run on Windows? Oh, you're not trying? Did you have a path issue as well, Lee? When you say /C, is that /C? Thanks, Robbie. All right, so let's wrap things up at this point. Yes, all right. We go back to here. The way these blog posts are constructed, and honestly, again, phooey. Damn you, WordPress. All right. Say that out loud. So at the end, you've got a bit of closure. You know what we did? We set up a way to run Docker on your workstation with boot to Docker. We run a container, our first container, Redis. We built an image. We called it My Small App because we were using the BusyBox thing. We changed the code and saw it reflected immediately without actually fiddling with our runtime. And in the current issue, we're talking about now how to, we're going to talk about how to manage containers and container management lifecycle, which is a lot of what Barrick is going to do now. So, I can, or if you want, all right. So, and you notice here, remember I mentioned James Turnbull's The Docker Book at the beginning? Read chapters 2 and 3 of the Docker book, and that will color in a lot of the details, things that like Manny was picking up, that Chris picked up on the volume thing and stuff like that. It'll color in a lot of those details and give you some intuition about what's going on. Now, before we go any further, I have this image. It's my application. I don't want it to be on my machine. I don't want to say, hey, ops, here's a USB key from the sneakernet to put in production, right? I need to put this thing somewhere. And so the term for that, Dockerish term, I don't know if CoreOS has adopted this either, is I'm going to go and register the image, which is why it's called a Docker registry. So, okay, so I'm going to go and, I like the idea of using the verb register because it seems right and good. Okay, so Barrick's going to help me a little bit. I have a key IO, Quay?
Pronounceable in different ways.
All right. So I have a Quay IO account, so I need a Docker login. Say that again? Oh yeah, thank you. Docker build -t my small app : yeah. Cool. All right. Hey, how would I know? You mind a quick digression here? How would I know that I actually have that file in the container now, specifically to Chris's point? I'm going to say Docker run -it. This is there's a ton of this in the second and third blogs about how to get into a container and muck about. What was the name of the image again? Docker images.
My small app.
Yeah, the image was my small app. All right, so Docker run -it my small app. And now I'm going to override the command. So instead of it running Python app py like it was in the Docker file, I'm just going to have it run the shell command. And look at what I got. I have a shell, NILS, and I can see, based on Barrick's suggestion, that it's that app.py is in the container. Okay. So yeah, Robbie. Docker exec -it. Okay, and that again, that's all covered in I think it's the second or third one in the series that I gave you as well. And that's why they're so long. Is I take pains to show you this is how these are some of the things I tried that were wrong. And this is what worked out, and this is what I learned from that. Very much like what Nick did in his talk earlier today, which I thought was just wonderful. I'm sorry? Oh, wow, thanks. All right, cool. So that's how you could get into, that's one way to get into a container and check if things are going. When I was trying to Dockerize Minecraft, oh boy, I was in and out of running containers all the time, pulling what's left of I don't have any hair left. All right, so I need a Docker login. What am I logging into? Well, I don't know. Let's see what help I can get. So Docker login. How do I log into key? Quay.io, like that? And then -u?
You'll ask.
All right. So I give it the name of the registry that I want to log into. Now this is important because Quay.io is like the public Docker hub in that it's a big public thing. But you can also have private repos, like you can on GitHub or the Docker hub.
You can also have Quay resell it on-prem.
Right. So a private registry that is Quay backed, or a private registry that's anything else. So I'm going to use my credentials. I don't know why it does this. It bugs me. Because I don't actually think it uses it. Last time I looked at the code, I didn't think it was using it. All right. So notice that it is actually writing your login credentials, including your password, in clear text down on the file system. Note. Okay.
Which is also why you can generate a password on Quay and have a special one. App-specific password for Quay.
Which is a better feature? Oh, sorry. I should not be judgmental. Yeah, it's come a long way in very short time. So now what I want to do is I want to push my image. Docker push. Now I'm already logged into Quay. I could push it to the public Quay, like so that everybody in the world can see it, but I need to use my namespace. And you know what? Now that I think about it, I need to tag this again, don't I?
Yeah.
Docker tag -h. So I need to say what image I'm tagging and then what I want to tag it to. So Docker tag my small app latest. Now what I want to do is I want to say my username. I think of it as a namespace. Oh, I'm sorry. Thank you. I need to say quay.io, right? Do I need the HTTPS and all that? Okay, thank you. bhempi, and then my Quay app, just so we can tell the difference. Colon latest. Or let's call it colon 1.0. That ought to do it, right? Now I'm going to push this. So what does it mean to push? It's like git push if you're familiar with git. I'm going to push this to same thing. Yep. And now it's sending the image list. So now what is it doing? Think back again to Nick's talk. It's checking to see if it has an image for the base image, and if it does, it's not uploading it. And then it's checking to see if it has the next layer and the next layer and the next layer. Each time it says no, it uploads it. Okay? So right now it's actually uploading those things across the wire to the real world. If you'll help me navigate real quick. Let's see. Yeah. So this is actually I'm logged in, as you can see, to Quay.io, and I cannot remember if it'll show it on a partial upload or not. Do you know? Yep, there you go. So there you go. You can see that we have our new image. Publicize it, all right? I don't know, man. This is kind of super secret stuff, right? Publicize. There we go. I think that's in the settings, right? Boy, this has really changed. Yay, make public. I like the fact that it defaults to making it private. That's kind of spiffy. It's also, no.
Okay, so why don't we do this? Should we just do a summary of what?
Yeah, sounds good.
Yeah. So while he's pushing his image.
I need to wash this off. I actually think I'm sick.
We only have a few minutes, so I just wanted to do an overview. what's going to happen is he now
Yeah.
on a, and so yes, it's been a very simplified version. That's like a laptop that works.
I'm gonna give one of the gals here borrow my laptop.
Your code is going to be saved somewhere. Repository is very good at tracking. Repository somewhere.
Registry.
Available to you to pull down into a cloud container somewhere. Up there, you don't have to reconnect your laptop, somebody else in the IT or your sysadmin folks or whatever group, and then say, okay, that's the one that they told us to deploy, and then let everybody do their own deploy. Right? So that's what we're going to do after this. Is Barrett?
Yeah.
I would have got it. Barrett is going to
And if you're using a different Redis image, I think you're using.
I'm using the canonical Redis image.
Using canonical
so
Redis
I would not bother.
Yeah.
Unless your company has a policy. For instance, if you're running Quay internally, right? You're probably going to put those canonical images in that internal one. Right. For instance, a very large retailer that starts with a Nord and like maybe make some storms but with a different spelling. Their people can't get to the internet. Period. So everything is internal. So they would have to do it that way.
So in that case, you still have to. In general, does that
point out that building and pushing locally is cool and that works great. You can also set up things like GitHub triggers and so on. So
that's actually in the second blog post.
Yeah.
Yeah. So, that's the whole container management thing.
Right. So all this just gets automated. Suddenly you have a container up on your registry ready to go.
And before you leave, I want to point out I don't work for CoreOS. I don't work for Docker. And I'm going to tell you this because it may not mean nearly as much coming from Barrick. If you want to learn to deploy containers and manage containers, like I'm using a DigitalOcean machine on
that's what I'll be using in my demo.
on a CoreOS image. If you use that CoreOS image, your use of Docker is enforced. You really don't have a way not to, right? And so you're going to have to work your way through all of the little things that you might just take a shortcut for otherwise. And what you're going to learn very quickly is it might just be a better way for you. So I'm not saying drink the CoreOS Kool-Aid straight away, but I am saying start with CoreOS so that you are limited to using, in this case, Docker images. And like I said, it's such a smooth and amazing experience that it's worth trying because it's very different from the Ubuntu and Red Hat stuff that you probably are familiar with. Okay.
I should just say, by the way, because they're right. So the coffee's drinkably hot. There's more stuff coming in about 10 minutes. If everybody here is planning, or those that are planning to, in the second half of the session, those are more than welcome, of course, it's continuing until they come. And then break then.
What I would recommend though is, if you haven't caught up to where you are right now, make sure you get that Quay account. Workshop with the container, you can still, we can help you push an image up to the Quay account, and therefore you can start from there. Yeah, caught up. And I gave in-state alleys and guys and stuff like that. Okay. Hey, if we don't get a chance to, because I'm going to have to leave in the middle of Barrett's talk, so I just wanted to say thank you. So thank you for both of you guys. Thank you. All right, break time.
There's no apt. USSH in. I'll mention that. Yeah, that's a great thing also. Oh, so I'll start with that as my first thing I said. I think it'll do the local directory. I think it'll do the local closest Docker file it sees, the one in directory, I think. Yeah, I think so. Slides from before, they're right here. Everything? Yeah?
Got your audio? Yeah.
Yep, I've got my audio going. Let's see. Yeah, so I'm Barak from CoreOS. Today what we're going to do is we're going to continue where we left off with, we have just pushed a Docker repository up to Quay, or in your case, I guess the Docker repository, it doesn't matter. Most importantly, it exists somewhere in a registry. And now we're going to play server admin. And we're going to deploy this into the cloud, like quite literally. And so I'm actually changing on my plan a little bit. We're going to go with this. Rackspace has been nice enough to provide us some temporary servers that shut down on Monday, but you can get one by going to iwanttoserver.io and using the code ContainerDays Boston as the event and your email, and it'll give you a server. And it ends up looking a bit like this. It'll give you an IP address and a root password. And so let's go ahead and log into our cloud server that we've just created. Root at IP address. Root password. Ta-da, we're running a CoreOS stable box in the cloud, ready to go. No magic. So one of the interesting things, though, is, sorry, what was your name in the audience there? Manny. As you pointed out, there is almost nothing on this server. And the reason for that, and I'll go back to my slides from yesterday and cheat. If I go over here, go to 5, send this to 5. Oops, sorry. 4, 5. There we go. Is most OSs, when you think about them as a distribution, contain things like Python and Java and all this that you can apt-get, or even things like Screen or tmux, or even simple terminal things that you might care about. But because in theory, CoreOS machines are totally cloud servers and everything runs in containers, because after all, you're going to run, you downloaded Python with your container, you based your image on Python, a specific version thereof. It's going to come along with for the ride, right, when you actually Docker pull this thing. So everything you need, if it's contained within your container, you don't need it on the host. Or even having a host copy is useless. Now you're like, but what if I want to SSH into the server? And the notion there is that you actually don't often. This is all automated, right? You want to be able to go and say, here, server, go, I never have to log into you. Go run some containers. And you have a whole cluster of these that are automatically doing it for you. I will demo that, actually, later on in this thing. But for now, I just wanted to finish off the example flow, because these are the codes we've got, and why not? So let's see. Cool. So hopefully you've got a root shell of your own on Rackspace, and maybe you've jumped ahead, and that's all right if you have. Question? It shouldn't take that long, no. You can also create another one. I actually have a second one here. What else am I going to say? Oh, yeah, feel free to interrupt me with questions at any time. Feel free to say, hey, what if I did this? And I might even try it, right? Like that's sort of what I'm going for here is just, let's play with it. Let's see what we can get running, because why not? Right, one of the few things, though, obviously, that you need on a CoreOS box is Docker, and sure enough, Docker is there. As is, incidentally, Rocket, to plug my shirt. We'll come back to that. Then let's go ahead and start running some containers on this CoreOS, because there's no screen, right? I can't actually launch it in screen. I can't do any of that. So, yeah, let's run Docker pull. Let's start with Redis, because we need Redis to back our service that we wrote in the last thing, you already ran this command on localhost, you notice it's the same command. This is one of the other great things about containers, right? Is that even if your development environment is this immutable thing that you can share and you can use everywhere, and like you were saying earlier, you build it once and it's all the same always. So too with your deployments, right? This is your prod server perhaps, and I'm playing, your SRE for the day. And now I'm doing exactly the same sort of thing. So I'm going to pull Redis. Fortunately, that does not depend on the conference Wi-Fi. It's in the cluster. It's in the cloud server somewhere. So I'm feeling a little bit better about that. And it's also a bit faster. And I'll go ahead and download. Any questions so far while it downloads? Yeah. Sorry, a second. Cloud config. I'll come back to cloud config when I actually start to go like clustering. Because right now we're provisioning these servers, Rackspace is doing it for us, right? They're giving us a root password and they're creating it. When we actually want to provision our own servers, which we will do later, then I'll talk about cloud configs. It'll be great. All right, cool. I have Redis ready to go. I can just docker run Redis -d, I guess. Uh, 60, whatever it is, but I shouldn't need to actually because maybe I do. I forget. Maybe I do. I think though that link when I do that next for his thing will actually link into. There you go. I'll answer your question the easy way. It's got a couple things. It's got Git and GPG and all the stuff you need to be POSIX compliant, and no compilers though. I mean, so Git, you'll have to get something real simple. No Python, no Node, no Ruby. What? No GCC, no Make. Yeah. Because you're building your infrastructure, you're building your app, and you said from Python run this thing, right? And Python is contained within your container. And it's in fact the specific version of Python you use to create it. So we could have a local Python, but we're going to get one anyway, A. And B, it's, this is as slimmed down as possible. The whole thing, the whole CoreOS image, du/. So, wrong. Let's see, df dash. The whole file system is df-h. Yeah, about 250 megs. And that's for the entire OS and everything running there. Yeah. The containers already contain the Python, yeah. So it has Python, so we can trust that. I mean, in some sense, though, like if I wanted to run an Ubuntu machine, right, I can do docker run Ubuntu. I think this will work. -i-t. I can never remember the argument order. I think it's -i-t. Of course, I misspelled it. Yeah, I have to pull it, but again, at least I'm a cloud provider, which is a bit faster. So, well, there it goes. That might take a while. Let's go ahead and open up another shell and log in. Cool. Oh, hey, there it is. I'm running, there it is. I have an Ubuntu now, and I have tmux, no, screen. Come on, Ubuntu. I have Python. I'm actually not sure what's in the default Ubuntu image, come to think of it. GCC? And yeah, is my path maybe messed up? Yeah, what's in user bin? Yeah, right? Well, I can apt-get it at least, right? I can go out and say, get me tmux. Sorry, install. There you go. Yeah, I am running Ubuntu, right? That's all I'm doing. So here's my tmux. Yay! So yeah, and so I mean, there I have an Ubuntu image, right? There's Ubuntu userland now living on top of CoreOS because containers. So that's exactly what they're for. What else was I gonna do? All right, so was I running Redis in the background? Docker PS, let's find out. Yeah, I'm running a Redis. It does have, see, it mentions the port it exposes, 2379, I think 6379. I think that it will work because of the link, but if it doesn't, well, we'll find out the hard way. And so then we just run the same command from before, which I think was dash link redis dash link. Also, I realized I didn't name it correctly. So I'll stop it and I'll expose it and we'll just make sure it works. Because I have to stop this one. Docker run dash name redis dash p dash name. I think it'll work without the dash dash. Let me double check that. It'll complain if I don't, so. Deprecated, but yeah, valid. I think so. If I did something else wrong. Dash dash port. Is that port? What was the command from before? What was the full command for running the container before? Dash port. That's what I thought. Dash dash name, dash p for port. Maybe I'm doing it. Dash p for port, dash d redis. Oh, it's already is. Yeah. There we go. Docker PS. Yeah, there it is, and it's exposed. I should be able to talk to 6379, and everything should be fine. Cool. Now let's run our other command, which was docker and port 5000 to 5000. Name my Quay app, because that's what he called it when he uploaded it. Because it's over here. We have Quay running. In fact, there's a nice Docker pull command I can copy. But let's just go ahead and do 5000, 5000. Not dash D. Let's run it. Let's run it dash T or I. What is it? We'll just do it that way. Redis. No, sorry. Quay.io / BEM fees. Oh. Sorry, I have my Quay app. Oh yeah, he called it 1.0. There's no latest. Oh, I forgot the link. Oh well. We'll stop it and run it. It'll be fine. Any questions about downloads? There it goes. Hey. Control C to quit. Yeah, cool. And I'll do run it except for dash link redis to redis. Except for that has to be earlier in the argument set. Hey, cool. And I think if I'm really lucky, like I said, I only practiced this a little bit this morning, so. Yeah, this port 5000. Oh, bingo. Plus, make it bigger. Yeah. And then if I refresh, it should count up because Redis is working behind the scenes. Yeah, cool. So I run both containers on a CoreOS box using Docker. And that's all pretty normal. And now it's deployed, right? It's in the cloud. You can access that same IP on your own box if you want to and make that counter go up really fast. All right, but let's get any questions now. I'll stop for there. Yeah. Good question. How does service discovery work and DNS mapping and all that? Yeah, that's actually a really fun bit because when you don't actually know, and we'll get to this again in a bit, but when you don't actually know what machine is going to run on, right, you'll need some sort of DNS or service discovery that needs to exist somewhere, right? Is this mapping from that IP? Yay, people are like pounding it, great. As well they should. This is how it works. And so yeah, there needs to be some way to find where your services are located. There are numerous ways of doing this. Most interestingly, I suppose, is the way Kubernetes goes about doing it. Is eventually, right, you're running a Kubernetes stack and you have your containers, and what it's doing under the hood, right, is a Docker pull and a Docker run. And what it also does, though, is it sets up like a final networking like layer, so each container has its own IP. And when it has its own IP, like that'll show up, but it's kind of in its own weird namespace. So they have, what do you call it, load balancer proxies. So you point at the one load balancer as your thing, and it routes it appropriately based on port or whatever. And being able to keep track of all that, that's kept track of in etcd, which is in a whole other story too. But we'll come back to etcd, and feel free to ask about any of that if you want me to. Go off on etcd, because I work on etcd. That's actually what I do. So, yeah. How many times have we gone? Poor little box. How big is this box? Right here? That's just the server. Oh, 66 times. Yeah. Yeah, it's just the output from the Docker running. Yeah, nothing crazy. 66 times. Good. Cool. Sorry, 2 times. What else? Okay, so we got that running. We have our CoreOS box running in the cloud. You got your service deployed. Maybe, unless anybody has any problems with it. So let's. Was that really that easy? It was really that easy. Yeah. Thank you for the. Was it really that easy? Yeah. Because you've already done it, right? The same thing you do in your dev environment, I just did basically, except for on a certain production server, and sure enough, it's higher, right there. 99 times past 100, 100 times. Cool.
So I have a question for you.
Yeah.
It comes up over and over and over again that within the
Mm-hmm.
and we've seen within you've got one container and you can configure it to talk to another container on your laptop.
Mm-hmm.
But the ports and all that kind of stuff aren't necessarily the same.
Mm-hmm.
And so therefore you hear people talk about like SDN
Yep.
that kind of stuff. And I was wondering what is the
Right.
But you got the Redis running in one container, you got the app running in the other. Obviously,
Okay.
how do you predict how to work?
How do you predict how you make it work? And that's actually the same question as how do I hit an IP from anywhere, right?
Right.
And you hit upon some of the right thing, which is software-defined networking (SDN), right? Which is we need some way of being able to say, I have this block of IP addresses. This is actually how funnel works. Is I have the entire space of 10.0.0. Whatever. And I'm going to give out this /24 to containers as they come up. And so this container gets this IP, this container gets this IP. And that's all well and good, right? You have a network layer, there's a network plugin for Docker. But where do they live, right? So it comes up and it gives me an IP, right? What does that actually mean? So part of then running a container sort of thing is having some way of registering your service with some consistent store. When your service starts up, say Redis, it needs to report to, say, etcd, like, here's where I am, here's where I'm living, I just got this IP, I'm on port 6379 or whatever it is. Yeah, this is my DNS entry equivalent. This is how you can find me.
So etcd is the store.
And so this is actually then, and to elaborate a little bit, so etcd, I'll back up a little bit in case, have heard of it, not heard of it? Show of hands really quick. etcd, aware of kind of what it's for and what it's doing? Just to, go for it, is etcd is a distributed key value store that's strongly consistent. And this is really important for things like service discovery, which is to say, I have a set of nodes that I specifically call out as being, here's where the data lives that's true for the entire cluster, and also agreed upon by the entire cluster. And then strongly consistent means that it also, I'll show you my slides from yesterday, why not? I've got the right slides for these things. So we'd have some sort of cluster of nodes, including a master or a leader that's been elected. This is the blue one. And over time, these nodes might go away, but as long as we still maintain a quorum of nodes, in the case of 5, that would be half plus 1, which is 3, then I can still make progress. I can still be able to take writes and be able to change things in the cluster. But if I'm smaller than 3, I might be, this pair might be on the bad side of a network partition, right? Maybe I just can't see those 3 because you've pulled the plug on me or something else has gone horribly wrong. And so instead of trying to guess at what might happen or accept writes or accept changes to where my services live or wherever anything like that is, it will just not respond, right? It'll stop taking writes. Everything that was true before is still true, so it'll respond to some reads, but it won't be able to, so what we call make progress, which is to actually change things. And the reason why we call it progress is because of exactly this. Changes to values look like a log. And over time, these indices move forward, and importantly, so like, here it is, right? I have, at time 1, I said put pet equals cat, and then I've changed it. Or this could equivalently be, for right now, my Redis is located at 122 to 168, whatever, right? And then that machine goes away. And then a new one comes up in its place. And now put Redis is at new IP, new port. And once it's kind of all hit consistency, once it makes progress, i.e. it changes, that's how it works, right? Because if we ask it at different times, we're going to get the wrong answer. So we want to make sure that this is what happens, which is when you say, get me the latest version, actually that's a quorum get, give me the latest version of whatever my Redis location is, right? That it actually goes and makes sure it has the latest version from all the machines, from the quorum of machines, and responds it. This actually means that the gets in this resolving is sort of slow, but it's consistent, which is the important thing. So you do caching tricks and so on to make sure that you can respond to DNS queries fast. But if ever it's like, but I can't find it, and you're like, okay, I got to update my cache, or watch as this updates. There's a lot of management that goes on with that, and that's why it's a really great question, and why I've spent so long talking about it now. But that's
So the etcd stores that, and then all the
Yep, it's used as a network directory, or SkyDNS is like a service discovery sort of thing that runs on etcd. Yeah. Yes. In fact, because I like demo things live. You have to bootstrap it, and it's a great question. In fact, thank you for that. That's perfect. I will use that to segue into the next part. Perfect question. How does etcd find itself, and how do you start a cluster? Great question. Love that question. You could not have picked a better question. Thank you. That's perfect. So let's go to DigitalOcean and spin up some servers. Let's actually create a cluster, right? Let's do this right now. Not sign up. I am already signed up. Thank you. And new. Good. That's my one little server box that I use all the time, but let's actually build some. Name this one CoreOS1. I'm going to create like 2 or 3 of them over time. But importantly, New York 3, private networking available, user data available. Now I'm going to use some of my prepared magic, which is right over here. I'm on a screen locally, so that's why you can't see it. And I'll explain it when I paste it in. Actually, I'll just move it over. So here's a cloud config, and this goes to your question now. So I get to talk about cloud config and etcd discovery at the same time, because it's right here. So what is a cloud config? Well, we're spinning up a CoreOS server that has nothing on it, or very little on it. It has etcd is one of the things it comes with, because you'll see that in a second, because we want to be able to run it and we want to create a cluster. So we want to be able to provision these servers from the time they get going, right? From word go. And furthermore, we know, so we want to be able to say sort of in systemd terms, and you can notice that like etcd service, fleet service, these sorts of things, not systemd, yeah, so right. What we should be running, right? What services do we want to start? Because this machine has never existed before. And we want to just be able to spin it up and say, here's your services to run. We can't get anything. We can't tell it what to do. So we have to be able to, we have to have just a little bit of configuration data that we want to run right at boot time, or right at once we get to run level 5 or multi-user mode, right? So yeah, and so here it is. This is the cloud config for a relatively straightforward CoreOS cluster. I'm running etcd2 because I'm going to run the alpha. etcd2 is currently in the alpha and beta channels, but not in the stable channel, which is another thing about that, the Rackspace one that's a little bit, it's just a little outdated. But etcd2 versus etcd1, etcd2 use it because etcd2 is really stable, and we've been using it in production, and it's really great. And etcd046, which was the version beforehand, is temperamental at best. So anyway, so how does etcd discover itself? And here's where we go, because there's a service we run called discovery.etcd.io, and this actually just sends you to the how the discovery works. But basically, discovery.etcd.io is itself an etcd cluster. Now you can either bootstrap yourself by saying, I know all the IPs. Here's where your partners are. I did it manually by hand. Or you can use the discovery service. And what discovery will do is if you say discovery.etcd.io, and this is exactly what I need to do. Discovery.etcd.io/new size equals, I did 1 before, but I'm going to do 3 this time. So I'm going to spin up 3 separate nodes and have them all talk to each other. And I'll also show you how they discovered each other under the hood as I do this. But I'm going to say new size is 3, and it will give me a token. It's a totally opaque token. It's just a URL. It's generated. There's nothing special here. But this is how we are going to bootstrap our etcd cluster. Paste it right in. So here's discovery parameter being, here's our token. Cool. We got it from here, like it says. This is a bit about what ports it's listening on. In particular, these are the peer advertised client URLs. This is the port it's going to listen on for clients. This is everybody trying to figure out like the key value store, using it as a key value store. If I want to put stuff in it, if I want to take stuff out of it, just like Redis or something like that. The peer URLs, that's a little more interesting. That's how etcd communicates within itself. So in order to make sure that things are consistent, and in order to sort of form this quorum. That's the URL it's talking to. And then it's just listening on those ports and internally and externally, and there we go. Fleet is a very simple tool that we wrote at CoreOS that basically acts as systemd but across the cluster. So Fleet depends on etcd, and Fleet will say, here are the different machines that are running Fleet. I can then run a systemd-like service and put it out somewhere on the cluster, and Fleet will take care of where it should go. And it's a very light orchestration layer. Now, Kubernetes is something like that's much more intricate and has a lot more cool features, and Fleet's just a very simple version of the same sort of concepts, though. So, and Fleet's again baked into CoreOS. So, here's our configuration for etcd. Here's our configuration for Fleet. And we're going to start them. Units, etcd2 service, Fleet service. Those are systemd services local to the machine. And just like normal, we're going to start them. Like that's equivalent to system service etcd2 start, right? Everything you'd run in systemd to start service. I'm also going to pass it my public key, because again, I can't write to another fun thing about CoreOS is the root partition and all those stuff read only. You can't write to it after. I mean, you can write to home and some other things that are mounted, but the actual system is totally read only. So how do I even get into the thing? Well, I have to be able to pass it at boot time the keys and other things that it needs. In this case, it's my public key, so that I can log into it. And this cloud config, incidentally, is online, and it's part of the CoreOS documentation. I literally copy-pasted it and put in my own public key. That's the only change I made.
So wait, I kind of missed something here. Basically, what I'm expecting. Talk to those containers.
We'll get there. Actually, yeah, that's once we get going and running containers on Fleet, then we'll get to that. It's to orchestrate a sort of like running things. Oftentimes that can even be running Kubernetes, say, right, on each machine in the cluster or across on some subset of the nodes in a cluster. Or
so it's more than just DNS stuff.
Yeah, this is actually, it's not even the DNS stuff. It's yeah, it's just IP addresses. It's not too complicated. Fleet, yeah.
Primarily focused on the IP
Yeah,
addresses.
primarily focused on looking for other fleets that have registered in the etcd cluster and talking to those. Because Fleet comes up, and the first thing it says is, I'm running, I know where my etcd is, like, I am part of this cluster. Right. And then the other fleets can look at that etcd key and see, oh, okay, I've got buddies out there. But, yeah, so let's go for it. There's my cloud config, paste it in. We're going to run CoreOS alpha, because why not run the latest? I think it also does the SSH key for you. I forget, but I just did both, because why not? And we'll create CoreOS 1. And DigitalOcean should just run. Any questions? Well, I'm building a couple of these. Yeah, I mean, DigitalOcean has given me a virtual machine with, in this case, I think it's 2 cores and a gig of RAM and whatever else goes along with it. So, yeah, I'm using their platform now as opposed to Rackspace. Yeah. I'm spinning them up one at a time. Yeah, this is just the first one. But I can actually prepare the second one while I'm doing this. Let's make it a little beefier, 2 gigabytes. CoreOS 2. And this should come as no surprise. Enable private networking so we can have etcd talking to itself without going over the wide world. Do that. CoreOS alpha. Switch key, you can make a droplet. Hey, CoreOS 1 is running. Let's do another one. Make it even beefier. Why not? And you notice I'm just copying the cloud config, by the way. It's the same configuration for each and every one of these. It's because the discovery token, which I'm going to talk about in just a second, because that's the next cool thing. And all the etcds have this token, right? We're starting them and initializing them with this token. And then so, yes, they're going to detect each other through discovery. And so each of these boxes, even though they're going to have wildly different IPs and wildly different things, they're going to be aware of each other, which is kind of cool. Cool. And actually, I'll start to log into the first one. Yeah. With the same token. So what will happen is actually etcd, the service will fail, but the droplet will come up. And Fleet will come up, and Fleet will know where etcd is, because that's also correct. But, well, Fleet might have a little trouble actually, don't think of it. But so if you want to spin up other ones that are not etcd nodes, that's actually probably the better way of doing it. And you specify that here's a single etcd server somewhere. You just need to talk to one, because it can do the rest. And that's, so yeah, so setting up your etcd cluster as sort of separate from every other node, that's kind of a good infrastructure thing, practice that we do. And that's because the etcd cluster is the stuff that, if a quorum of them go down, there will be massive repercussions, right? Like that's a page somebody at midnight sort of situation, right? Now, hopefully that shouldn't happen. In experience, it doesn't, right? We actually just had, for discovery, because like I said, discovery itself is an etcd cluster. The sysadmin for CoreOS, he hasn't logged into that box since we last updated it, and he hasn't had a single error. So it's been kind of nice. And then we last updated it a month and a half ago, 2 months ago. He hasn't even logged into the box. He hasn't even seen it carried. So, hey, my 3 things are up. Wildly different IPs, that's good. Increasing size. Let's see if I can log into one of them. And let me just grab a new terminal. So, Core is the default user of CoreOS. Oh, hey. I've used this one before. How's that? Yeah. Yeah, remove from my known hosts. Cool. I'm logged in because it had my public key. If I look around, etcd cuddle members. Sorry, member list. Hey, there are my 3 nodes. How did it do that? Now I get to answer your question the right way. Because discovery etcd.io, when I go to this, you'll notice this is URL. If I actually go to the URL and I were to like post or put to it, and I am an etcd node and I'm coming up, I have this URL. I do a put request to put myself and my details into etcd discovery.etcd.io. And once there's a number of them, size equals 3, so once there's 3 of them, then everybody knows, I see 3 servers, I'm ready to start. So because they all agree on that, in fact, the size is right there. Should be there. Yeah, it's there. But yeah. I mean, it's just JSON, right? And here are the 3 keys. The key is, this is actually the same SHA that I have here, right? And each of these keys is the individual machine hash with its information. And you notice these modified indices are relatively sequential. People may be spinning up things too on top of us. That's okay. And yeah, there we go. They're talking to each other. And furthermore, if I go back to 6, does this need to be bigger too, or would it help? Yeah, I'll make it a little bigger. No, I want preferences, profiles, speed, and begin. Yeah, there we go. So yeah, I can do etcd cuddle. What is it called? Cluster health. I'll actually go out and check, and sure enough, my cluster is healthy. I have each of the members as a member. I should be able to do etcd cuddle get foo. There should be no foo key. Yeah, so I'll put foo bar. It's sorry, set foo bar. Sure enough, and if I get it back again, so that's how I can put keys into etcd. It's just an HTTP call, nothing fancy there. In fact, if I do dash debug, I think it'll show me the earlier on. Yeah, it's the curl equivalent thing for getting it. So it's just an HTTP call. Cluster endpoint, so it's discovered the other parts of the cluster. So that's going. So yeah, I have, not only do I have etcd cuddle, but I think I have Fleet ready to go because I started it with my cog config. So, and Fleet then talked to etcd, ran its keys, so it should find list machines. Oh, did I not fix that? That would be really sad. So I'll get response from localhost. Oh, of course, because it's not listening. Is it listening on localhost? No, it's not listening on localhost. No, it's just trying to find an etcd, and it's trying right now localhost. I think that's because that's how I configured it. Let me see if that's true. No, that's not true. Huh. It's listening to 4001, so it should be listening on interfaces. Like I said, I did not necessarily. Let's see if I can log into a different one. Why not? That one seemed to work. At least it found the Fleet. Oh, it's because it's not Fleet list machines. I'm an idiot. Fleet cuddle. Yeah, okay. I was trying to run Fleet the daemon, not Fleet the control plane. So, Fleet control. Yeah, there it is. Fleet control list machines. There they are. Sure enough, that worked fine. And there's a whole bunch you can do, Fleet things that it does. So you can, we have no units, we have no nothing. So now we get to do the cool thing of deploying containers on the cluster. Like this is what we all came here to do. So Fleet CTL. So I'm going to cheat a little bit, but I'll explain why I'm cheating. I'm going to run Redis, and I'm going to run Redis somewhere. And that's going to be cool when I actually get it there. Where did I put that? Here it is. So let's run Redis. So what this is here, I'm copying out, is just a service file. If you're used to systemd, this should look pretty normal. And what it's going to do, right, is it's going to run a Docker. It's doing these exact commands, right? It's everything we know before and loved before. Docker run name Redis. It's going to pull it first. It's going to remove it when it's done and kill it when it's done. You'll notice that I'm not calling docker-d. That's because systemd is taking care of it. Systemd is going to get all the output and run it to my systemd logs, and it'll run like a normal service, except for clusterized, sort of. So let's run it. Fleet cuddle. What's the right command for it? Start. No, let me ls make sure I'm here. Fleet cuddle. Start Redis service. Oh, come on.
Just out of curiosity, when you start up the service.
Oh man, did I run by running Fleet? Did I mess it up? Don't tell me I messed it up. Bad. Let me try the other one again. To copy. Interesting. One of them went away. It's probably because I was running Fleet on one of them, that one, and then I messed it up somehow. That's what you get for. Yeah. Yeah. Mm-hmm. Mm-hmm. Yes. So. Right. So how do I save data? And persistence is a problem. And there was a whole panel thing on this yesterday because it actually is a really tricky problem. So one thing you could do, right, is you allowed tags for machines in Fleet, for example. You could just say, this machine here, that one's got my persistent storage volume, whatever it is. Only run Redis on that, and then it will do the right thing. But you could also but then in the general case, though, that's really hard, right? So I have a database somewhere, and I want it to be able to go down, and I don't care about where it should end up in the cluster. And I should want to, so how do we deal with this, right? And then you start having to think about distributed file systems and, putting things on an NFS or a lot of things that were talked about in that meeting. But that's where it really gets also very interesting is, how can like this, what I'm doing here, right, is I'm making the machines, the compute, work as one big machine. How can I make the disks work as one big disk? Right. That's really the question. Something like that. Yeah. So, and that's part of why containers are interesting, but still fairly new, because a lot of these things, like, we don't, it is buildings, what we say at CoreOS, right, we're building Google's infrastructure for everybody else. Like, and that includes things like, we need to make a GFS, or we need a GFS-like thing. We need big table or Cassandra-like thing, I guess. You could also do that, right? Is you can run some sort of distributed key value store of your own, or you could run a HDFS. You could run a.
Well, I just wanted to end with this thought.
Mm-hmm. Yep.
Find common.
Yeah, and I'm a database guy, right? That's what I like to do. etcd is a kind of a database, except for we're working mostly on smaller data sets, but strong consistency, right? But I work on graph databases in my spare time, and this is my sort of thing. And the answer is like, really, it's kind of an information question, right? It's like I have to store it somewhere. I can't get around that, right? There's a information entropy theoretical problem, right? It has to live somewhere. And so and that somewhere may or may not be where you want it to be on a cluster, right? It could be anywhere, in theory. But so the trick is, how can I try and maximize my ability to put the compute right where the information itself exists? And that's a really hard problem. That's why it's not progressing as far, because it's a really hard problem. Yeah. Yep.
Well, and that's a.
Mm-hmm.
Pattern that I've seen where
Fix itself.
Redis or
Self-healing. It went out, lost its connection, tried again. The fleet service noticed that it couldn't connect, or there was a competing fleet service or something. It gave up for a little while. That one went away. It tried again. Like, when in doubt, retry. So. Yeah, exactly. Because that's equivalent to a machine going down. The machine could have gone down for an update. The machine could have gone down for any number of things. And Fleet could reschedule, some of the jobs that were meant for that thing on new things. Kubernetes does this all the time, right? Is I can schedule failed jobs or things that seem to have gone away. If they come back, I want to deschedule one. And doing this juggling of keeping it up. Good point.
Complicated thing. Anyway, listen, I'm gonna get running here, so
Yeah.
keep going. I'm just
Cool.
gonna quietly remove myself.
Yeah, we were talking about how the machine came back actually, because it's self-healing, and this is kind of high availability and clusters in general. Why do we want to do this? It's because of actually that reason right there. Machine goes down, machine goes away. We don't care. We keep running. We keep serving our customers, and there we go. So Redis. See if I can do fleet kernel start. Redis.service. Boom, I launched it somewhere in the cluster, in this case on that machine, which that's an internal IP, so it's talking within its own little cluster world. But if config, is that local by chance? No, it's not even me. It's somewhere else. I can take a look at where it ended up. I can do list, what's the right thing? List units. Yep, so Redis downloaded and is running somewhere. That's cool. Can we actually now? I'm going to do a little bit of a cheat. Instead of doing service discovery like you suggested, I do, which you're right. I should do. I am going to insist for the next thing, which is the same app we ran before. My Quay app, right there, same thing. Except I'm going to insist that it runs on the same machine as a Redis service. Xfleet machine of Redis service. And otherwise, it's pretty much the same thing. So it should launch this thing on the same .88 that we see there. And then the two will be able to talk to each other because it's localhost and it's easy to find. Yeah. Yeah. So it's out there somewhere. Pipe into Quay app service. My Quay app that service. That's what we called it, and I'll keep calling it that. I'm just the SRE today. And if I do I'm really lucky. 88. Right on. Why it chose it randomly for Redis, and then it chose it specifically. I said wherever Redis is running, run there, and so it chose 88 specifically for this one.
So what did you just do?
So I ran the Quay app container that we had on the same machine as the Redis. So I subverted your question of how do they find each other by saying they need to run on the same machine. That was my little bit of sleight of hand right there. The real way to do it would be to have some sort of way of saying, like a link or pass in a environment variable which says, okay, based on this, tell me.
Right. Hey, you know what?
Right.
So I just want to kind of wrap one idea up.
Yep.
So some of you might, and
oh, it failed. Why did it fail?
your application finds obviously the find that container so that static. And what that means is there's nothing stored there. So you can one of those that you spin up needs to know where the database is, or maybe whatever, other services. And there's this evolving pattern I've seen where you have, and it might be, I'm still learning etcd.
Stop.
It says the problem is you don't want to keep talking to etcd every single time you talk to a database. That's like, well, you don't want to know where's the database again? So when it's happening, so there's this pattern I'm seeing where the platform or whatever it is that's managing this environment will push one of the instances it spins up. How Cloud Foundry does it. Oh, your apps all need to talk to the database. Well, rather than and whatever the controller is that's managing all this thing, it might be Fleet or whatever. It's going to say, let me get that information. I'm going to inject it into each one of the app can always just talk into the database is and the keys and all that kind of stuff. Right? That way, the round trip is lightning fast because it's in memory. You got to bring down those instances, bring them back up. That's what I've seen as a pattern. I don't know if that's how you guys are doing it,
Yeah,
but
sometimes.
Right. Thanks a lot.
Yeah. Well, still not quite going. Actually, right. I should be able to do Fleet Could find out why. Good question. Thank you. Journal. Hmm. Yeah. Oh well. What time is it going to be? Just H Soccer. So it's trying to log in and failing. That's an interesting idea. But why does Redis succeed? I mean, if Redis is succeeding, I should be able to hit it, actually. Come to think of it. From the world. Let's try that. Not localhost, but what's the equivalent for 88? Actually, let's just log into things until I find it. This is not 88, it's the other one. So it's the last one I didn't copy yet. Beefy one. That may be why it's choosing it, incidentally, is I have different sizes of machines. One of them is much beefier than the other. Maybe it's trying to do with the right thing, which is, hey, we can give it a lot of resources. Oh, hey, so yeah, there's Clear App Service failing locally on this particular machine. So now I'm like, yeah. Mm-hmm. There can be logic, and there may even be logic I'm just unaware of at this moment. But yeah, you can totally write logic, and this is like the greater scheduling problem, right? Which is, how do it, like, given that I have these containers running here, is there more resources available over on this machine? You know, does this one maybe have a better network connection? Does this one have enough disk for what you ever need? You can ask all these questions and start having all these constraints. It becomes a bin packing problem, actually, at the end of the day, when you think about it that way. Yeah, so it's a interesting. There it is again. That one's going away. It's weird. Let's go ahead and just journal cuddle way up. What's the? I can never remember the right journal cuddle command. Pulling repository. Oh, ha! Check that out. tag latest not found, and I forgot to add colon 1.0. Same thing I did earlier that I didn't do. Cool. So I will go back to this one, which has the unit files. Yep. Change the service to include and I need to also expose port 5000. Cool. Fleet Cuddle. There's a way with Fleet. I know you can look at what failed, but I don't know off the top of my head. Destroy my way up the service, and then we're going to launch it again from the local copy. Actually, cool. Did that work, or that's the status? Okay, it's in pre, which means that it's trying to download. It's probably Docker pulling right now, all the different layers to make this happen, right? And on 88, and sure enough, it's running. Cool, cool. Now can I curl this? And if I can curl this, can I do it from the web? And if I can do it from the web, ha! So let's go ahead and connect to it from the web, because why not? This was the one, beefy. Yep, it's beefy. Cool. If config, what's its public IP? Actually, I know this answer. It's not. And we'll go to our web browser. I don't know why it's slow. Maybe it's the conference Wi-Fi, and I've just been doing everything over SSH. Yeah, yeah. I have been seen 2 times. Yeah, perfect. I just launched this. And now, let's see if I can do any more cool things with Fleet, like multiple Fleet units. Never remember. I mean, it should be relatively simple to scale this out. Let's go back to here where I've got the files. I shouldn't need to, but Fleet cool. List of units. Yep, they're both running. Now can I do like, what's the right thing for? Start? Maybe can I just start another one? Oh, that works. Start another Redis somewhere. That's already running. There's a magic command to make this happen. Fleet replicas. Yes. Oh, hey, yeah. I'll try. I will destroy the Redis. I'll destroy my app. I'll run them again. This time. Oh, that's what I can do. Yeah. Cool. And I picked 3 different machines for each, trying to keep it. It knows it's running on one, so it says, that one's only running one. I can move it away. And so now, exactly the question you asked earlier, which is, it could make some decisions and have some logic about where to place it. MQA1. I don't want to type it that many times. And the only reason I'm naming them different things is because they need different service names so that Fleet can call them different things. But things like Kubernetes, which is much more advanced, can do just automatic replication of these things. When you say I want to run 5 replicas, it'll do the right thing. So it's just a quirk of Fleet, I suppose. And there's probably a better way to do it if the Fleet authors were here, but I'm improvising, so. And of course, these will all be different counters, right? Because it's 3 different Redises. But if you want to start talking about, having these Redises discover each other, you could, extend this, right? And so they'd have one consistent counter, and have the others be replicas. You could really start playing. Because now you're talking about how do I create a greater cloud, right? How do I actually configure my applications? And that's just all systemd units, right? Which is I can create something that goes out to etcd, pulls a thing, does a little simple service discovery, discovers who the master is currently. Master election, that's a whole other thing that comes up. Any questions? I think that's kind of the end of where I'm going with this, is I was able to run the one, and now I'm just going for a victory lap if I get this one. But questions are the best things, because then I can. Questions? Anything? Good idea. Yeah. That's a great idea. Let's try that. Actually, let's take a look at FleetKittle, because what FleetKittle, when it says list service, right, or list units, one of them failed. Oh, because it's running on the same server. That's why. Scheduled, and so it's got the port used. And yeah, so does etcd have this list? So if I do etcd cuddle, there's git, and there's a recursive flag. ls-r, sorry. Yeah, so at least version 2 of the etcd API looks like a directory tree, right? Nothing crazy. So that's going to change with version 3. It'll be just a flat key space with binary keys. But sure enough, it's not. Where is it under ls hidden? That's the update engine. That's keeping track of what CoreOS things are running. Is under / underscore etcd. There's a hidden folder in version 2, which is also kind of weird. In fact, it looks like underscore etcd, yeah. So yeah, Fleet is holding it somewhere. I'm not sure exactly where Fleet's holding it. My guess is it could be underscore etcd. Underscore Fleet, maybe. How much you want to bet? No. Anyway. They're there. They would have to be, because in order for list units to say something, as well as then going to the other beefy box. That one. Yeah, Redis 2 failed here. Cool. They'll agree. In order for them to all agree, they have to have some sort of consensus between them. So. Yeah, I think I could set in Fleet a option for try somewhere else if it fails, or because there's that whole xFleet block. That's in Quay xFleet, so I can say it should run on the same service, or I could do restart policies and that sort of thing. So yeah, and like I said, Kubernetes is sort of the very advanced version of this that we're ultimately going toward too, right? Tectonic, incidentally, is all the things you see here today. CoreOS, and in fact, I'll pull up my slide because that's a great example. 5, yeah, slides. is the entire stack as I see it, and that's what my talk was about. But basically all of it, right? CoreOS, etcd, Flannel, which is our networking layer overlay, Kubernetes, and Rocket. And then, oh yeah, I didn't launch any Rocket containers. I could do that for a little bit because Rocket's built in. So I can, one of the cool things about Quay, incidentally, it'll complain, but what's the name of the container we built? Quay will actually translate from Docker containers to Rocket containers on pull, like dynamically. So that's another cool thing about Quay. So feed my Quay up. You won't be able to find Redis. Oh, yeah, fetch. Yeah, I need to be. What's wrong? 202. Oh, Air downloading the signature file. That HTTP status code 202. 202 is good. 202 is, what is 202? 202 is accepted. Whatever. Oh, I know what's happening. It's converting it right now. That's why it's giving me a 202. Accepted means I'm accepting this by a future processing to do. So it's converting the image as we speak. But Rocket will also verify signatures. So that's one thing it's doing right now is it's computing ACI to ASCII. It's computing the signature and signing it. So containers, we want to make, one thing we're really big about at CoreOS is security. That's why root is read-only, a bunch of other things. So how do you know that the Docker container you pulled is actually the Docker container you thought you were pulling? And the only way that can happen is if the bits actually, A, MD5 sum correctly, and B, are verified and signed by whoever it is you're pulling from. And so if you can guarantee both those things and you trust the signature, like public key encryption style, then you're good. You actually know these are the bits you meant to run. And Docker has like none of that. So you have to always skip the verification. Incidentally, Rocket can fetch Docker containers, like just straight up Docker containers. -- insecure, what is it? Sure. -- insecure, because that's insecure, skip verify. So we'll skip verifying. Docker, Redis, fetch, sorry. Yeah. So I'm using Rocket to do this. And you can imagine I could actually put this into my systemd file as well, right? And I could use Rocket to deploy across my cluster just as easily as I use Docker. For the same reasons, I just need to change how that thing executes. It's downloading the layers, just like you'd expect. And so I'm running a Docker container on Rocket instead of systemd and on a cluster in the cloud. Da, 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 da. Castle in the cloud, yeah. Hey, Rocket, go Rocket. Incidentally, Rocket doesn't need any sort of Docker daemon or anything to run. So this is just, once it actually fetches, which will take a little bit, but not too long, it's going to run as a normal, systemd thing. So I think I can just do Rocket run and have a Redis. Doesn't need, it'll try to fetch it, it'll see it has it, and go. I just saw any use, I'll take that. But, so if we could stop Redis.service and Redis 1 to 3 services. Whatever. Anyway, there it is. Yay. Cool. There's my Redis running in a Rocket container, taken from a Docker container, you could take it from Quay, you could take it from anywhere. Docker Hub, whatever. So Rocket's pretty damn flexible, and it works really well. So yeah, nice. Yeah, I'll sign off because people are coming in. But any further questions while I finish up? No? Anything? You've had a lot of great questions. You've been a great audience. I mean,
When's Rocket ready for prime time?
it's in the CoreOS image right now, and that's why I was just showing off. So you can run your containers just as much as you like.
So do you feel that it is as stable as you'd like it to be for well, I mean, at least in time being?
It's progressed a lot in 6 months, and we're coming up close on. So like real soon now, 1.0 is what we're aiming for.
6 months ago it was like.
6 months ago it didn't exist.
Well, okay. 4 months ago, when the announcement was made, this works, but do not use it.
Oh yeah, when we announced it 6 months ago, yeah, it just worked, and now it's actually been going fairly well. Yeah, I will disconnect.
Sorry, no, I mean, that was rude of me.
No, I totally should sign off.
First of all, thank you very much.
Yeah, thank you.
We're almost done. The last survivors. Look at us. We should be proud of ourselves. So thank you, everybody, especially since it turned out not to be raining today, for sacrificing your Saturday to be here. It's been obviously, we can stand and organize as much as we like. It's the people who come who make the conference what it is. Where's Borja? Where's he gone? There he is. He's right in front. Thank you for making it all the way down. This organizer guest. Yeah, the obligatory thanks. You've been to a bunch of conferences, so you've heard this all before. Obviously, to the nerd for giving us the space. We won't talk about the AV, but no, everything worked out great. We had Wi-Fi for most of the time, and don't look a gift venue in the mouth. Obviously, amazing thanks to all the organizers like Boyd and Anastas, Jared, and some volunteers in the back, me, for making this happen. But all the speakers, everybody okay? Two final things. There's a. Oh, well, let me finish. You can do it in a second. There's a Thank you.
Boy bigger than me, so.
Next year, Andrew is going to ask you for your help to do this again and make it better. Make sure that you're watching for that request and make sure you honor it. When I ask for help in Austin, I have to turn away half of the people at least. Make Boston that awesome, please. All right? Thank you.
Thank you, Boyd. So I've already had a few people who said how would anybody who's interested want to stay in touch. I'm going to send out one more email on the mailing list for this event. And yeah, we might set up a Google group or something. So we'll see how that'll work. Around this time next year, hopefully we'll be doing this again. And yeah, the call will go out. There is a swag, the last two things for the day. There's a swag table at the front where there's just a bunch of random stuff. Pick if you want something. I'm sure we all have like a million water coolers or whatever. You have one last crack at everything that's at the food. If you want another cup of coffee or water or whatever, Coke from the fridge, just do that. Then we'll pack that all up. But before we all do that, I've just cleared a little bit of space around the big, irritatingly rotating display. Let's just all crowd around that, and somebody will take a photo, and then we can tweet that and be happy, and then we can all go home. Thank you very much.